Welcome to the introduction of data analysis and Python basics. Well, in this course, we're going to learn everything about data analysis using Python. And before getting into the more practical part, we have to know a bit about what data analysis is and how does data analysis work with using Python. So, what is data analysis? The process of gathering, organizing, cleaning, and analyzing data in order to find relevant information, make inferences, and aid in decision making is known as data analysis. Using a variety of methods, including statistics, visualization, and programming tools, it assists in locating patterns, trends, and connections with data. To put it simply, data analysis transforms unstructured information right into insightful logic, or let's say knowledge. So let's check out the real world examples of application of data analysis with Python. It starts off intelligence for business. Python is used to examine market trends, consumer behavior, and sales data. Decision making is supporting and insights are visualized with the aid of tools like Seaborn, Matplotlib, and pandas. Medical care. Python is used by hospitals to evaluate medical records, forecast illnesses, and enhance the treatment plans. Predictive analytics makes use of libraries such as TensorFlow, scikit-learn, and NumPy. Money. Python aids with risk management, fraud detection, and stock market analysis. Analyzing data in real time with the use of tools and APIs such as stats models and pandas such as Data Reader are quite effective and helpful. Online shopping. Examining pricing optimization, product recommendation system, and user behaviors are also part of Python data analysis. Website data is gathered, cleansed, examined, and applied to enhance user experience just by using data analytics of Python. Analytics for sports. Teams examine opponents' tactics, match data, and individual performance. Coaches can improve their tactical decision making with the aid of data visualization. Analysis of social media. Python may use NLP, which is natural language processing tools like NLTK and Spatie to analyze tweets, comments, and posts in order to determine the trends, public moods, or even the brand popularity. Observation of the environment. Use big data sets from tensors or satellites to analyze meteorological data, pollutants level, or trends in climate change. All of these are quite helpful for data analysis using the basics of Python. So now let's get into the first class of how we're going to install Jupyter, or let's say the Python analytic tool. The first thing that you're going to need to do is you have to make sure that Python has been installed on your device. Now, if you don't have Python installed on your device, it's totally fine. Just click or open any of your browser and search for download Python. Open up the first link that appears up on your screen and download the latest version of Python available. Now, I already have it installed, so do the same thing. Just click on download. If you're using a different OS, such as a Mac, Linux, or maybe others, just click on the platform and it will be downloaded. Now, after it is downloaded, from here, I'm going to search for Python. Okay, we have this Python over here. So this is the exact file that you want to do. And just what you want to do is just click on open file location. Now, when you open file location, this is the type of platform you will see. Then right click on this again and click on open file location again. Then what you want to do is first off, let's open up a notebook. Okay, so we have a notepad on the side. Now, there are a couple of things that you have to do. First off, we're going to take this exact file and take this exact location and paste it on this notepad. Another thing that you want to do is click on scripts, then take the same thing, copy and paste that location too. Then what you want to do is close off the folder and open up CMD. Now make sure to run it as administrator. Now after you run it as administrator, what you want to do is, as I already have Python installed, first off, you want to type in Python -- version. Hit on enter. You can see Python is not recognized. So it's totally fine because sometimes it will not be recognized. So just open up the windows again and search in for environment variables. Hit on enter, go off to environment variables and click on path. You can also go off over here and select on path over here and click on edit. Then click on new, and over here, just copy and paste this. Like first off, press on cancel. I'm going to copy this, Control C, click on path, click on edit, click on new and paste it up. Press on OK. Do the same thing on the script file, Control C, click on edit, press on new and paste up the script file. Press on OK and press on OK again. Okay, so basically you are good to go with this part. Now it is basically very simple. You want to type in the same thing on CMD again. So let's close this off. I'm going to click on save, or you can just, not save it. Now let's open up CMD again, run it as administrator. Then over here, what you want to do is type in, first off, Python space -- type in version. Now you can see that after putting in the variables or the environment variables, it has been detected. Now I'm going to also make sure that pip is also available. So type in pip version, hit on enter, and you can see we have both of these. So first off that you want to do is first off install Python. After installing Python on your desktop, then locate the directory where Python is installed, and I showed you these steps or the exact step that you want to follow. Make sure to follow up that step because it is very important. Now the next thing that you want to do is obviously you have to make sure you install Jupyter on your PC. So type in pip, type in install Jupyter, hit on enter. Now after you hit on enter, you can see it is going to collect up Jupyter and it's going to take a bit of time. Just make sure you are connected to the internet throughout the whole time. You will see that it is going to basically keep on continuing until it hits end. And there's going to be also a script where it's going to show me off that, there's like a couple of things that has been collected and installed, and a lot of them has been decrypted, and also a lot of them has been loaded. So just wait until the whole thing has been done until you can see your console again where you can type. So I'm just going to show it to you like at the end of how it looks like. So let's just skip this part. Okay. Now, after the whole thing has been done, you will see something like this. A new release of pip is available. You can install the pip. You can do that, but I'm just going to keep it like this. And these are the last scripts that you will see on your screen if the whole thing has been done successfully. So after that, what you want to do is you want to check like again if Jupyter has been installed perfectly, because if it can detect of the version, then it means that it has been installed perfectly. So type in Jupyter, put in -- type in version in the same way, hit on enter. Then it will show you the exact versions that has been installed on your device. Okay, so basically it is how simple it is to install Jupyter Notebook on your device. Okay, so the next thing that you want to do is obviously open up Jupyter Notebook on your device. It is basically very simple. You don't even need to install anything, but obviously there is, kind of, let's say a software which you'll be able to use to run Jupyter, which is Python launcher, okay, which is PyLauncher. It is also known as Anaconda. Okay, you'll be able to use that, but if you don't want to go through that hassle, I'm just going to show you how you are going to enable it and use Jupyter Notebook on your device directly without the installation. If you want to install it, just type on over here and type in download Anaconda. type in Anaconda Navigator. From here, just click on Anaconda Navigator and click on download. It will allow you to use Jupyter Notebook from there, but if you want to use it directly without this hassle, then just open up your, let's say, folder, or let's say any of your files. So this is the exact file that I have opened up, and I'm going to make sure to keep it just like this. Okay. Now, after you keep it, what you want to do is you can name it however you want, but I'm just going to keep it new folder. Now over here, what you want to do is you want to go off to the script and type in CMD, hit on enter, and this exact file or this exact folder will open up on CMD, and the exact folder will run along with it. Now, the next thing that you want to do is basically very simple. You just want to type in Jupyter and space notebook. That's all that you need to do. Type in Jupyter notebook. Okay. Jupyter notebook. Hit on enter and just wait for a bit until it opens up on your screen. Now you will see that whichever browser you want to use, I'm just going to click on Arc, which I most of the time use. And you can see this is exactly how it will open up. Okay. This is how it will open up. And this is exactly how Jupyter Notebook is. So we have the name of the folder, which has been selected. And over here, if you want to apply in a new notebook, it is also quite simple. What you want to do is just click on new over here and type in the exact thing. Let's say you want to make a notebook, which is Python 3 IP kernel. So click on that and a new notebook will open up on your screen. Now from here, you can type in print, open parentheses, single quotation, type in hello. Close off the parentheses, and you just want to type in shift and enter. And if you see that hello has been printed, then it means that your setup is successfully complete. So that's it for this class. From the next class, I'm going to be showing you everything about Jupyter Notebook, what you need to know, and how you'll be able to apply the command snippets or the code snippets to get on with data analysis. So thank you for watching this video again, and without any further ado, let's move on to our next class. Welcome to our first class of data analysis with Python. Well, this class is mainly the Python basic refresher, and the first part that we're going to cover up are the variables and data types that you can show and also represent in the Jupyter Notebook. So without any further ado, let's hop onto our class and open up Jupyter Notebook on our device. So as you can see, I have Jupyter Notebook running, and now I'm using, let's say, Microsoft Edge. Another thing that you want to make sure is that you need to keep these open, because this is the exact, server that is going to link up successfully onto Jupyter. Okay. Now, the next thing that we want to do is we're going to click on new and IP3 kernel. Now we're going to go off on home. Let's just close off this. And over here, I'm going to click on rename. Let's say I'm going to put in variables and data types. This is the exact folder or the exact name of the file that I want to keep. Now you can see it is going to select up the Python kernel. I'm going to use this always start the preferred kernel. I'm going to press on selected. In that way, Python will always be selected. So first off, I'm going to start off showing you the short and effective style of, using the examples and introduction to the variables and data types in Python. First things first that we need to know about are the variables and data types in Python for data analysis. Such as if you want to know about basic variable assignments, let's say, I'm going to put in variables such as a name equal double quotation. Let's start off with Alice. Let's move on to our next line. Now we have that. Now I'm going to cut off this and I'm going to customize this line. Then I'm going to type in age equal, let's say whenever you are using numericals or integer values, you don't have to put in double quotation. In that case, 29. The height of that person is going to be 5.9. And the next one is underscore student. I'm going to put in as false. So basically, the name that we're using is a string. Whenever you are using a numerical, it is known as an integer variable. whenever you are using, let's say 5.6, or let's say not integer, then that is also termed as integer, but specifically it is known as a float number. And then if you define in false or true, it is known as a Boolean value. Now, one thing that we can do over here is that I'm going to close off these lines, and then I'm going to make sure I put in print, open parentheses, then define the variable, such as I want to print the name, I want to define the age, I want to print out the height, and I want to print out if he is a student or not. Is student. Close off the parentheses and hit on enter. Shift and enter, that's all that you want to do. Now in this Jupyter notebook, you can hit on enter as many times as you want. But if you want to print it out and if you want to hit on enter, press on shift and enter, and you will get the exact result, such as Alice, 29, 5.9, and false. So these are the basic variable assignments that you need to know before starting off anything. And then you're going to learn how to use and import pandas and NumPy, which are core libraries for data analysis. So in most cases, you're going to need that. So first off, type in import pandas as PD, and then type in import NumPy as NP. Then hit on shift and enter. And you can see sometimes these modules are not going to be found on your screen or onto your device. Now, it is totally fine if it does not work or if it cannot be, detected on your device. What you basically have to do is you have to import, or let's say you have to install pandas on your device and also NumPy. So first off, that we want to do is we want to cut off this, and here put in the exclamation mark first, type in pip install pandas NumPy. Hit on shift enter, and then it will be installed. Then type in the same thing and hit on shift enter, and you will not face any errors. So these are like very important for you to import pandas and NumPy, because this is, almost mandatory for data analysis. Now, you're going to work with a lot of numerical data. You have to know about how you can work with numerical data. First off, I'm going to create an array. Let's say I'm going to have a sales array. Now, when you are defining a lot of numerical values, now you can see over here, we did not put anything. So first things first, you want to do something over here. Type in the secondary bracket. Now, when you put in secondary bracket, you can use more than one numerical data, or let's say one integer value. Such as I'm going to start off with 260, comma, let's say 700, comma, I'm going to put in 400, comma, I'm going to put in 120, comma, and 500. Then close off the secondary bracket. Now, we're going to convert it to a NumPy array. So type in the variable such as sales underscore, and now we're going to turn it into an array. So type in array. After that, type in equal, type in NumPy for NP, put in dot, type in array, open up the parentheses and define the controller of the variable, which is sales. Close off the parentheses. Now you have to perform simple analysis, such as I want to print out, open parentheses, double quotation, total sales, colon, then close off the quotation. Here, I'm going to put in a comma and type in sales underscore array. Put in dot sum as the function, open up the parentheses, close off the parentheses, and close off another parentheses at the end. If you hit on shift and enter, you can see the total sales is this number. Now, if you want to get the mean value, do the same thing, print, double quotation, type in average sales, colon, quotation, comma, sales underscore array, put in dot, put in the mean value, close off the parentheses, and there we go, we have the average sales, which is 396.0. If we want the maximum sale, type in print, open parentheses, maximum sales, colon, double quotation, comma, sales underscore array, dot max, open and close the parentheses, and hit on Shift Enter. And the maximum sales is 700, as you can see. So this is basically how you're going to work with numerical data and also perform simple analysis on this numeric data. Now, you're also going to work with string in a specific data frame. If you want to work with string in specific data frame, first off, you have to create a simple data frame. Now, there are specific methods of creating or working with a specific data frame. It could be an external data frame or it could be an own created data frame. In that case, let's just start off with the most basic and create our own simple data frame, such as name, put in PD, then type in dot data frame. In this way, a data frame will be created. Open up the third bracket, single quotation. Let's start off with the name. Now put in the array, single quotation, as you're working with, variables. So let's say I'm going to put in Alice, comma, single quotation, Bob, comma, single quotation, let's say Larry, comma, I'm going to put in Charles. After that, close off the secondary brackets. I'm going to create another data frame or another category of that data frame, such as I'm going to put in department, colon, secondary brackets. Let's say one is going to be for HR, one is going to be for management, one is going to be for hotel, one is going to be for IT. In that case, we have our department variables done too. Now here I'm going to close off the brackets and the third bracket. Now the next thing that you want to do is you want to initiate the string operation, such as lowercase department names. Start off with data, secondary brackets, and I'm going to put in department lower. So here I'm going to put in DEP underscore type in lower. Secondary bracket and close off that. Put in equal data, secondary brackets, put in single quotation. Let's say I'm going to put in the controller of department, secondary bracket again. Now all of them are string values, so type in str, type in lower. Open and close off the parentheses, and now I'm going to type in print, open parentheses, type in data. Shift and enter, and you can see sometimes we're going to see an error. You can see this is how it is closing off. I'm going to close this off at the beginning and end and press on shift and enter. We have this one over here again, which is the secondary brackets. We're going to check out the secondary bracket right over here. Basically, it is totally fine. But here we can see we forgot to put in a comma. So we're going to put in one comma and hit on shift enter. In that way, you can see Alice is for HR, lower department HR. We have Bob in management, Larry in hotel, Charles in IT, and we also have a specific index value. So this is basically how you're going to work with strings in specific data frames. Now, the next thing that we're going to learn is about booleans and filtering. In that case, let's start off in the new cell. First off, I'm going to have a data cell. Here, I'm going to define the salary. Here in the salary, type in equal, secondary brackets. Let's say I'm going to put in a value, comma, comma. There we go. Close it off. Now, we're going to create a Boolean mask, let's say, who earns more than a specific data. In that case, I'm going to start off with a specific value. Let's say in this case, I'm going to put in high earners equal, and that is the specific data frame. Let's say here I'm going to put in the salary as the controller, secondary brackets, and then put in the condition. Let's say we have 1, 2, 3, 4, 5, 6, 7. Here we have 7 values, so I'm going to put in who earns more than 1, 2, 3, 4, 5, 6, 7. There we go. Who earns more than this? Or let's say I'm going to put in 4, 9. Okay, this is the exact value that I want to put in. Now we're going to filter the rows using Boolean, such as type in first off print Open up the parentheses, type in high earners, colon, backward slash, n, double quotation to close it off, put in comma. Type in data, secondary bracket, type in high earners as the controller. Then close off the secondary brackets and close it off with a parentheses. Hit on Shift Enter and you can see some of them might show you off as an error, and it's totally fine. Now, if it keeps showing you off as an error, what you want to do is that it is basically getting the data from this array too. So there are basically 4 people. So here I'm going to put in another digit and try hitting on Shift Enter. So let's say I'm going to reduce the value over here. Let's say 5,000, 4,800. I'm going to put in like this and put it like this. And here I'm going to also close it off. Let's say who earns more than $499, or let's say 4,500. Shift and Enter. And let's say it is still showing me off as an error. After putting in the value, I'm just going to put in S over here, and there we go. We have the high earners such as the name, department, lower salary, and the index value. So this is exactly how it is going to work when you are working with booleans and also filtering. Now there are a couple of things that you have already learned, or let's just get into the summary, such as integer value, float value, string value, boolean value. And all of these are Python built-in types. But you can see we also have applied in list, NP array, and PD data frame. These are data structures for data analysis using Python. Now, if you want to connect all of them together, it is also quite simple. Let's just show them all to you in one line, or let's say in one cell. First off, we're going to make sure we import all of these. So here I'm going to type in import numpy as np. I'm going to import pandas as np. Then I'm going to create the basic variable assignment. Let's say employee underscore name equal double quotation. Let's put in Alice. After that, I'm going to put in employee underscore age equal, let's say 29. Employee underscore height equal 5.4. Then I'm going to put in is underscore student equal to false. Then I'm going to print the basic info, print open parentheses, let's say employee. After that, I'm going to put in info colon, then put in double quotation, put in comma. I'm going to put in employee underscore name, then comma, double quotation, put in this straight line. After that, you have to put in the age value, colon, double quotation to close it off, comma. Here I'm going to put in the employee age. After the age, put in comma, do the same thing for the next one, double quotation. Here I'm going to put in the height. After the height, I'm going to put in colon, double quotation, comma. I'm going to put in employee underscore. I'm going to put in the employee height, comma, double quotation, this one. And here I'm going to put in the is student or not. It is also quite simple to put in. Just type in student over here, colon, double quotation, comma. After that is student. Close off the parentheses, and basically that's all that you need to do on this line. Now let's move on to the next line, and let's start off with the numerical data analysis using NumPy. I'm going to put in monthly sales equal variable, let's say 250, comma, 300, comma, 400, comma, 150, comma, and then 500. There we go. And put in the sales array equal np dot array. Then put in open parentheses, type in monthly sales. Close off the parentheses, type in print, open parentheses, double quotation, n slash, and make sure to put in the slash as backward and then put in n. And here I'm going to put in sales analysis. After that, colon, quotation, and close off the parentheses. Type in print, open parentheses, double quotation, and type in total sales, colon, quotation, close off the parentheses. And another thing that you want to do over here is put in comma. And here I'm going to put in sales underscore array, then put in dot sum. There we go. Put in print, open parentheses, quotation, type in average sales, colon, quotation, comma, sales underscore array, dot, then put in the mean value, then type in print, open parentheses. Let's say the last thing I want is the highest sale, quotation, comma, sales underscore array, put in dots, and put in the max value. That's it. Now move on to the next line. Now let's work with creating a pandas data frame, such as a tabular data frame. So start off defining the data equal pd dot data frame. After that, open up the parentheses, third brackets. Here I'm going to start off with the name, then put in colon. Here I'm going to start off with, let's say, Alice, comma, let's say Bob, comma. Then I'm going to, let's say, first off here, I have to put in quotations. After Bob, I'm going to put in Charles. Now close off these secondary brackets, put in a comma. Then I'm going to put in the department. Then put in colon or quotation close, secondary brackets. Here I'm going to put in HR, secondary brackets. I'm going to put in finance, single quotation. I'm going to put in, let's say, marketing. That's all that you need to do. Close off the secondary bracket with the comma. Then I'm going to put in the salary of each and every one. Secondary brackets. Let's say I'm going to start off with 30,000. I guess that's it. Comma. Let's say 40,000. Comma. And then I'm going to put in 60,000. That's all. Close off the secondary brackets. And here I'm going to first off close off the third brackets and then the parentheses. In this way, this should be done. Now let's do string manipulation, such as making department in lowercase. So type in data, secondary bracket, single quotation, department. There we go. We have department underscore lower. After that, single quotation, close off the secondary bracket, type in equal data. Now define in department over here. Single quotation, close off the secondary bracket, type in dot str, type in dot lower, open and close off the parentheses, and now you have to put in Boolean filtering and finding high earners, such as high underscore earners equal data, secondary brackets, defining the controller as salary, close it off. Now here, which one earns more than 50,000? There we go. Then I'm going to put in filtered underscore data equal data, secondary brackets, high earners, close off the secondary brackets, and then you want to print out the data frame. So just type in print, open parentheses, double quotation, backward slash, and type in n, type in employee data colon, then type in backward slash and type in n, double quotation, put in comma, and type in data, close up the parentheses, type in print, open parentheses, double quotation, backward slash, type in n, high earners, high earners, type in colon, backward slash, quotation close, comma, and type in the controller, filtered underscore data. That's all that you need to do and put it on this cell. So as we have the value, just hit on shift and enter, and you can see we have the employee info, such as Alice, age 28, height 5.6, student false, sales analysis, total sales 1600, average sales 320. We have the high sale 500, employee data, department, Alice, HR, salary, and all of them. And we also have the high earners, names, department, salary, and also department lower. So in this way, it demonstrates all basic data types, uses NumPy for numerical analysis, uses pandas for string operations and Boolean filtering, and is a copy-paste ready for Jupyter Notebook. And I'm also going to be having all of these, files in my resource folder. So obviously you will be able to copy and paste it and check it out if it is working or not. So thank you for watching this video up till the very end, and hope you understood about everything in this class. If you still have any confusion or any question, then feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of data analysis using Python. Welcome to a new class of data analysis with Python. This is still a part of the class of Python basic refreshers. So in this class, we're going to cover everything that you need to know about loops and conditionals. In my previous class, I've shown you about variables and data types. So in this class, we're going to continue and advance with loops and conditionals. Now, another thing you have to keep in mind that as this is the basic part of Python basics, make sure do not skip any part of this class, because it's going to basically foundation the basic part of Python, which is going to help you in further classes of this course. So let's get into the specific folder and let's open up Jupyter Notebook. So as you can see that we have opened up our file over here. Next thing we're going to do is we're going to follow up the same step by opening up CMD, and here type in Jupyter Notebook. Hit on enter, and let's wait for a bit until it opens up our server. Now over here, we're going to click on new, IP kernel tree. Let's close this off and let's rename it. Click on rename, and let's type in loops and variables. Let's open up this now. Now, before getting into the practical part of this class, what we have to learn about is what is list and what are variables or what are dictionaries. Now, let's go through them one by one. So first off, what is a list? A list is an ordered, changeable, mutable collection of items which are defined using a square bracket, or also known as the secondary bracket. If you have no prior experience, then it is totally fine, because we're going to cover up all of the basics that you need to know in these classes. Now, first thing that you need to know about is how you are going to create a list. Now, a list can also refer to an array of data. Now, it could be a collection of integer value or a collection of string values. String values are basically, alphabets or words, which I've shown you in my previous class, and integer are numerical values. It can also be float values having decimal value. So let's say in this case, I want to define in a specific array of data, or let's say a list. Now type in fruits. Let's say I'm going to put in fruits as there are going to be multiple of them. Double quotation, let's say apple, comma, cherry, comma, and let's say banana. Now close it off with the secondary bracket and hit on shift and enter. Now you will see that we will not get any output because we did not print any or we did not put any function to represent our array of data. But a new cell has been created without showing me any error. That means the array of data or the list that we have entered is validated. Now we can initiate a lot of these functions or do a lot using this exact array. Now let's say I want to access a specific list item from the array of data, or let's say from the list. So if you want to access any list item, you also have to know about indexing. If you have no prior experience to Python, it is totally fine. But in most coding formats or snippets, there is a specific format. Such as you can see we have 3 data, such as apple, cherry, and banana. In most normal cases, what people are going to do is that the first one is apple, so that the index is 1. Cherry is number 2, so it is number 2. And then we have banana at the third, so it is, or it should be number 3, right? But it's not how it is in coding. In coding, what you have to know is the first one always starts off with 0. So apple is 0, cherry is 1, and banana is 2. So indexing always starts with 0. If you want to print out any of these specific variables or this listed data, you have to first off put in print, which is the most normal case. Then define in the controller, or let's say the specific variable, or which array of data should you want to print. Let's say you want to print something out from the fruits variable. Now, as you can see, that the list of data was defined using the secondary bracket. In the same way, you have to print out the index value first. So you have to put in the secondary bracket to validate it. In this case, I want to print out cherry. So cherry is at index number 1. So I'm going to put in 1, close off the secondary brackets, and then the parentheses. Hit on Shift Enter, and you will see cherry will be printed. If I want to print out apple, you have to put in 0. Shift Enter, and we have 0. If you want to put in banana, 2, then print it out, and you will see banana will appear. If you want to print out 2 variables, hit on Shift Enter, and you can see this is not how it works. So you have to put in like this, or in most cases, you have to put in only 1 variable. In that case, it will only be able to use one of these variables to print it out. Okay, so let's just keep it as 1. There are also a couple of things that you can do using this specific listed data, such as you'll be able to change any item. Now, if you want to change any item, you can see the first line that is still being appeared up as fruits, as apple, cherry, and banana is still being validated. Now, whenever you want to change an item, you also have to define from which index do you want to change. Let's say I want to change out banana. So banana is basically on index number 2. So first off, you have to define in the controller as fruits, secondary brackets, put in 2, close it off, type in equal, double quotation. Let's say I want to put in strawberry instead of, the banana. Double quotation and hit on Shift Enter. If you see you don't face any errors, that means it has already been changed. If I try to put in print, put in fruits, secondary bracket, and put in 2 here, and close off the parentheses and hit on Shift Enter, you will see instead of getting banana, we're going to get strawberry. Now over here, what I can do is that we can put in 2 over here, and we will still get strawberry. So before this line, it was showing us banana, but now it is showing us strawberry because it has been changed, or the array of data or the listed item has been changed using the function of controller and the index value, and then putting in the exact string that you want to put in. You can also put in integer value if you want to. If you want to put in integer value, you have to put in, let's say, 1, 2, hit on Shift Enter. And if I put in print over here, open up the parentheses, type in fruits, let's say 2 over here, close off the parentheses, and now you will see that we have 12 over here, which has been changed. So this is basically how it is going to work. Now, what I'm going to do over here, I'm not going to keep it 12 because I'm going to change it to a fruit name. So let's put in fig over here. There we go. Now we have fig right over here. We can also delete this and it will be empty again. Now, the next thing that we're going to learn about is how you can add an item in the listed data. Now, whenever you add in an item, it is obviously going to start from the next one. So after banana. So which makes it the index number 3. 0, 1, 2, 3, whichever we put in over here. But we're not going to put in any data like typing it over here. Instead, what we're going to do is we're going to append it. So type in fruits, then type in dot, type in append. Open up the parentheses. Let's say I'm going to put in grapes. Close off the parentheses and hit on shift and enter. And you will see that no error has been found. So type in print, type in fruits, secondary brackets, put in 3, and hit on shift and enter. And there we go. We have grapes right over here. That means that like the third one has been applied. Now, let's learn also how to remove an item. If you want to learn how to remove an item, there is also a specific function for that, which is the remove. Type in fruits, put in dot, remove. Then open up the parentheses and put in which data you want to change. Let's say I want to remove in cherry. Close off the parentheses and hit on shift enter and cherry will be removed. Let's type in print, fruits, put in secondary bracket, and cherry was on the index number 1. So if I put in 1 right now, it is going to show me fig, or let's say banana, whatever it is. You can see we have fig. If I put in 0, it's going to show me apple. If I put in 2, it's going to show me grapes. So you can see the name, which is you can see has been removed. So cherry has basically been removed from the specific list. If I put in 3 over here, we can see there is specifically no 3. So we can put in 0. We can put in 1. Let's put in 1 over here. And we can obviously put in 2. And obviously we have removed one of the items that we don't want to use. Now, the last thing that we need to know about lists is looping through a list. If you want to print out all of these at the same time in one lines, like each of them in one lines, you have to use the for function. So type in for, type in fruit, in the controller fruits variable, colon, then you have to put in, let's say, print, then type in open parentheses and type in fruit. So you can see this is how it is going to look like. So for fruit, in fruits. Okay, now I'm going to keep it like this, hit on shift and enter, and this is how it might look like. But if you don't want it like this, it is totally fine. Let's close off this line and type in for fruits in fruits. Type in print, type in fruits. Shift enter, and there we go. We have apple, we have fig, and we also have grapes. And obviously the cherry and banana has been removed. So this is basically how you are going to work with specific lists in Jupyter Notebook. Now let's move on to the next part. It's about dictionaries in Python. So what are dictionaries, or what is a dictionary? A dictionary stores data in key value pairs, which is defined using curly braces or the third bracket. Now let's learn them step by step. Okay, so the first thing that I want to do is we want to create a dictionary in the same way we created lists. Now here, I'm going to put in, let's say, student as the variable name, equal, third bracket. Let's say I'm going to put in name, colon, double quotation, as we're going to define in string value, let's say Alice. After that, put in comma, double quotation age, colon, let's say age is 21, comma, double quotation, grade. Here, I'm going to put in A grade. Close off the third bracket. Hit on Shift and Enter. So, another variable has been created, or something like a list has been created. But it basically is like a dictionary. Now, in the same way, you will also be able to access these values in dictionary. It is also simple and quite similar to the list. So type in print, open up the parentheses, define in the variable as student, secondary brackets. Let's say, what value do you want? Do you want the name? Do you want the age? Or do you want the grade? Let's say I want the name. Close it off with the secondary bracket and the parentheses. Now you can see we have Alice as the name. If we put in age, we have 21. If we put in grade, it will show me A grade. But if I put in Alice over here, you can see it is an error because it is defined using this colon over here. So you have to put in the controller such as name, age, or grade, or whatever you put in. I can also put in more category over here. Let's say nationality. Let's say USA. Okay, so if I put in nationality, you can see I have to make sure you have to put in the exact same thing. Now you can see we have A. I'm going to copy this. And paste it. Now it might also show you off as an error. It's like a couple of times, but there is basically a specific, data which it validates. So what we can do is we can remove it. Okay. Now I'm going to do is I'm just going to change it to name again. Now the next thing that you want to do is changing the values. So first off, put in the value or the name of the array, such as student, double quotation, and I want to change the name, or let's say the age value. Close off the secondary bracket, type in equal. Let's say I'm going to put in 25 in this case. If I hit on Shift Enter, this is how it looks like. I'm going to copy this, paste it over here, and instead of name, I'm going to put in age. Now you can see it has changed into 25 where we have put in 21 over here. Now let's move on to the next one. It's about adding a new key pair value. Let's say I'm going to put in student. Now you can see what I did over here. We have put in nationality, but it also detects and validates a specific category. Let's say if I want to put in a subject, it is going to be validated. So if I put in subject, secondary brackets, double quotation, let's say subject over here, double quotation to close it off with the secondary bracket. Type in equal, double quotation, and type in math. Now here, I'm going to put in Shift and Enter. Now you can see this has been validated. So if I put in print, student, secondary brackets, and put in subject, double quotation, close off the secondary brackets, and close off the parentheses, Shift Enter, and there you can see we have math as the subject. Okay, so this is basically how you're going to add a new key value pair. Whatever you put in over here, let's say maybe I want to put in science, like whatever you put in is going to be validated. Okay, there we go. Now, the next thing is how to remove a key value pair. If you want to do that, now in list, what we did was remove. You can try doing the same thing over here, like for the list, which is basically student and type in dot remove. Then after that, open up the parentheses, double quotation. Let's say maybe I want to remove in subject, but it is not going to work like this. Okay, because now it is detecting up as like a dictionary. So for dictionary, you have to put in DEL, then put in the controller value, Now here, I want to remove in the grade. So here, hit on Shift Enter, and then the grade will be removed. So if I put in, let's say, Control C, Control V over here, and if I put in grade, it will not be detected because there is no such thing as grade which is available right now. Okay, now the next thing or the last thing that we need to know about is looping through a dictionary. In the same way, we have to use the for function for key, then put in comma, value in student dot items. Open and close off the parentheses so whatever is inside is validated. Now here, I'm going to put in print, open up the parentheses, F, double quotation, third bracket, and put in key, close off the third bracket, and put in colon, and then open up the third bracket and define in the value. In this way, everything has been validated. Now close off the double quotation and also the parentheses. Hit on enter or shift enter, and you can see the name is Alice, age 25, and the subject is science. So now we have learned every basics that we need to know about, lists and also dictionary. Now let's show you a finally combined code snippet of lists and also dictionaries. So I'm going to move on to the next one. First off, let's work with lists. I'm going to put in fruits, or let's just remove all of these. I'm going to put in fruits over here is equal, like these secondary brackets. I'm going to put in apple, comma, double quotation, let's say banana, double quotation, comma, double quotation. I'm going to put in mango. Secondary brackets. Then I'm going to put in fruits. Let's say fruit 1. Put in equal, double quotation, orange, fruits, fruit dot append. Open up the parentheses, grapes. Then I'm going to put in fruit dot remove, open parentheses, double quotation. Let's say I'm going to put in mango, close it off. I'm going to put in print, open up the parentheses, put in double quotation, fruits list, colon, quotation close, close off the parentheses. Here, I'm going to try putting in fruits on all of these cases. Here, I'm going to put in for fruit in fruits, colon, print out fruit. So we are basically done with the fruit section. Here I'm going to put in print, open parentheses, single quotation, backward slash, n. Now let's work off with dictionaries. Student equal, third bracket, double quotation, name, Alice, comma, age, let's say 21 in this case, and let's put in the grade value, A grade. That's all. Third bracket to close it off. Students, then put in double quotation as age, double quotation to close it off, secondary brackets, equal, let's change it to 24. Then I'm going to put in student, let's add in another one, which is subject. Close off these secondary brackets, put in, let's say, math. Then I'm going to put in DEL, student, and here I'm going to put in double quotation or secondary bracket first. Let's remove grade from here. And then I'm going to put in print, open up the parentheses, double quotation, student dictionary, double quotation to close it off with the colon, close off the parentheses. I'm going to put in for key, comma, value in student dot items, open up colon. Here I'm going to put in print f double quotation, third bracket as key. Now after this, what I'm going to do is first off, you have to make sure you put in the third bracket over here, close off the third bracket, put in colon, third bracket again, and define any specific value. In this way, this is done. Close off the parentheses and hit on Shift Enter. So you can see we have the fruits list, apple, orange, grapes. Student dictionary, we have Alice, age 24, and subject is math. So this is how you'll be able to apply and make it effective at the end, and also make sure that everything runs along in one code snippet. Okay, now I'm going to be saving all of these files, with the resource folder with this course, so you don't have to worry about it. You can check out the, code snippets and also try practicing along. So that is it for this class. So thank you for watching this video up till the very end, and hope you understood about everything. If you still have any confusion or any question, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of data analysis with Python. Welcome to another class of data analysis with Python. In this class, I'm going to be showing you everything that you need to know about loops and conditionals. Now, this is the last class of Python refreshers or Python basic refreshers, so make sure to follow up and not skip any part of it. And I'm also going to be showing you an effective method, or let's say an example of how you'll be able to apply loops and conditionals in most cases. So let's get on with our class by opening up Jupyter Notebook on our device. So as you can see, I have opened up Jupyter Notebook. Let's click on Python 3 IP kernel. Let's rename this loops and conditionals. Let's open up this file and let's see what we have to go through. Now, before getting into the practical part, we have to learn about what are loops and what are conditionals. So let's start off with conditionals. So conditionals are used to make decisions in code based on certain conditions. So these conditions can be based or can be of different criterias, different requirements, and whatever it is. So there are three basic conditional statements. They are if, elif, and else. Now all three of them has individual specific task. If runs when the condition is true. Elif runs when you have to check another condition if the first one is false or not. And you are going to use the else function or the else conditional to check if all conditions above are false or not. So let's show you the steps of how you're going to apply the basic conditional statements. Now, before you are going to learn about the basic conditional statements, you have to make sure you have your data available, such as let's create a variable. Let's say x is going to be equal to, let's say 15 in this case. Now, start off with the first basic conditional statement, which is if. If x is greater than 10, then I'm going to put in a colon. Then you're going to put in print, open parentheses, positive number. Close off the parentheses. Then after if, we're going to run the elif. And this checks another condition if the first one is false. So here I'm going to put in elif x double equal 0 colon. Here I'm going to put in print 0. Then I'm going to put in the else conditional. This else conditional is going to run when all conditions above are false. So let's say print, open parentheses, double quotation, negative number. Now, if I hit on Shift and Enter, you can see it is a positive number because it is greater than 15. If I put in 1 and hit on Shift Enter, it is going to show me negative number. So it is not equal, or it is not greater than 10. Now, if I put in it is equal to 0, it is going to show me 0 because it is matching up to 0 value and it is working in this case. Okay? So this is basically how it is going to work. Let's say I'm going to put in just 10 in this case. Okay? Now, the next thing that I'm going to be showing you are the loops. So loops are basically used to repeat a block of code multiple times, such as there are various types of loops. One is the for loops, and the next one is the while loop. All of them, or both of them, have also specific function, such as the for loop is used to iterate over a sequence like a list or a range of data, and etc. But the while loop repeats as long as a condition is true. In that case, what we're going to do, let's start off with the for loop. If you want to define the for loop, first off, you put in for I in range, open parentheses, 5. Here, I'm going to put in print I. Hit on Shift Enter, and you can see it goes up to like 4 because the number is 5, but it is not going to be equal to 5. So 0, 1, 2, 3, 4. But you can see we have 5 of these values because the index starts from 0, not 1. Now, let's see about how you can use the while loop. It repeats as long as a condition is true. So if it is true, it is going to keep on continuing. In that case, let's put in the count function equal 0. While loop, while count, let's say I'm going to make sure this is greater, or 5 is greater. Then I'm going to put in print, open parentheses, define in count. Then I'm going to put in count plus or equal to 1. Shift and Enter, and you can see it is equal, or it is going to go up till 4. Okay, let's close off Copilot. Now here, count, I'm going to put in 6, and you can see it is not equal to 6. If I put in or start off from 1, it is going to start off from 1. If I put in 3, it's going to show me 3, 4. If I put in greater or equal, and on Enter, it is going to go up till 5. So this is how it is going to work up. If you put in equal before, it might not work. Okay, so put in equal, and you can see it is not going to work. So you have to put in the greater or less than sign first, and then put in equal. In that case, it is going to be equal or greater than 5. There we go. You can see, let's put in a colon, and there we go. This is how it's going to work. So basically, you'll be able to combine the loops and conditionals, and this is where the power of Python shines, because you can use the if statement inside loops to apply conditions during iteration. There are also step-by-step methods which you can follow up. Okay, first off, what we're going to do is basically we're going to use a specific code snippet. Let's say I'm going to start off with for number in range, open parentheses, 1, 11, close parentheses, colon. Let's say if number, put in percentage, let's say 2 is double equal to 0, then what I'm going to do is I'm going to print out, open parentheses, if double quotation, third bracket, number, third bracket is even. Okay, double quotation, close of the parentheses. After that, I'm going to put in the else function. Then I'm going to put in print, open parentheses, f double quotation. Let's say I'm going to put in number, third bracket to close it off is odd. double quotation to close it off, and hit on Shift Enter. And you can see 1 is odd, 2 is even, 3 is odd, even, and then 10 is even. Now you can put in from 1 to 11 too, that is also up to you. But you can see as we have it up to 11, it has gone up to 10. You can put in equal or greater than 11. In that way, 11 will also be, applied. Okay. Now, let's show you how you'll be able to use both of these together and make a simple structure. Okay. Let's say we're going to make a number guessing game. In that case, first off, what you have to do is you have to set the correct number. Let's say I'm going to put in correct number equal, let's say in this case, 7. Now we're going to create a loop to keep asking the user. Let's say start off with the while loop. Here I'm going to put in while true, colon. Here I'm going to put in a specific guess equal to int, integer value. I'm going to put in the input value, open up the parentheses, double quotation, guess a number between 1 and 10. Colon, double quotation, close off the parentheses 2 times because we have 2 of this open up. Now we're going to put in the conditionals to compare the guess. So for that, we're going to put in the if function. If guess is greater, or let's say lesser than the correct number, you can see this is how I'm going to put it. Here I'm going to make sure I put in underscore over here so it is validated. Correct number. I'm just going to copy it, Control C, and I'm just going to paste it. Correct number, colon, put in print, double quotation, let's say too low. Then I'm going to put an exclamation mark, try again. This is all that I'm going to put in. Close off the double quotation, close off the parentheses. Here I'm going to put in elif, guess, close off that, correct number, colon, print out, let's say, too high. Put in try again. And the last one is the else conditional. Print, open parentheses, correct. You guessed the right number. This is how it's going to be. And then I'm going to put in a break, which is going to exit the loop. Hit on Shift and Enter. Here I'm going to put in, let's say, 1 in this case. Hit on Enter. You can see it is too low. If I put in 2, like too low, put in 5. If I put in 9, you can see now it is showing me too high. If I put in 7, you can see correct, you guessed the right number, and then it's going to exit the loop. So if you correct, like if you guess the exact number, it is going to close off right there. Okay, so basically what it does when you use the while loop, it creates an infinite loop until the user guesses the number correctly. When you put in the input function over here, it allows user interaction. If you put in the if, elif, and the else, it provides feedback based on the games, such as the conditionals. And when you put in the break on the else or wherever it is, if it meets up the criteria, it exits the loop once the user gets it right. So this is how you'll be able to use loops and conditional in data analysis of Python. So thank you for watching this video up till the very end and hope you understood about everything in this class. If you still have any confusion, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of data analysis with Python. Welcome to another class of data analysis with Python. In this class, I'm going to be showing you simple Python calculations and list iteration. Well, if you've seen my previous classes, then this class would be very simple for you because we are going to show you step-by-step guide to demonstrate this simple Python calculation and list iteration effectively in Jupyter Notebook. This is going to help the beginners and also advanced user to understand the concepts clearly using small, tested cells and visual output. So make sure not to skip any part of this class because it is going to be very important, and I'm going to be using some basic arithmetic operations and a lot more. So without any further ado, let's move into our class and let's open up Jupyter Notebook on our device. But first off, let's open up the folder. So as you can see, I have opened up the folder. Let's just open up CMD. Now type in Jupyter Notebook. Hit on enter, and let's just wait for a bit until Jupyter Notebook opens up on our device. Now, as you can see, we have opened up Jupyter Notebook. The first thing that I want to do is I'm going to click on New Python 3. Now let's close it off. I'm going to rename this file. Let's say list iteration and calculation. Now let's open up this folder. Now the first thing that we need to do is, first off, you can name the cell in specific ways. Now you can use specific cells to explain the goals of the notebook, such as your notebook is basically going to demonstrate how you're going to perform basic arithmetic calculation and iterate through a list in Python. So the first thing that we need to do is we need to apply in basic arithmetic operations and also a list. Okay. Now, first things first, we have to define the basic arithmetic. Now we're going to hold two specific variables, A, such as A is going to be 10, or let's say 11, and B is something around, let's say 6. Let's just keep it like 12 and 6. Shift enter, and there we go, it is done. Now we're going to do some basic arithmetic operation. So type in print, open parentheses. I'm going to put in print, open parentheses, double quotation. I'm going to put in addition. After that, colon, close off the quotation, put in comma, A space plus B. In that way, we will have our addition done. Now I'm going to apply in more over here because I don't want to apply it in different cells. Let's put in subtraction, colon, double quotation, comma, A minus B, print. Let's say the next one is going to be multiplication, comma, A, then put in an asterisk sign and put in B. In the last one, type in print. Let's say this is going to be division, colon, quotation, comma, A, then put in slash B. In that way, you'll be able to validate it better. Close off the parentheses and hit on Shift and Enter. And you can see the addition answer is 18, subtraction is 6, multiplication is 72, and division is 2.0 or 2. So you can break this into separate cell by using better understanding at the same time. So you can see that we have arithmetic cell by one. So in 1 by 1, what you can do is you can type in A equal 12 and B equal 6. Now you're going to press on Shift and Enter. And what you can do, if you want to add it up, you can type in A plus B. And it will also give you the answer. If you want subtraction, A minus B, and it will also give you the answer just like this. In the same way, you'll be able to do multiplication and division, such as A asterisk B, and also A division B. In this way, you'll be able to see that everything that you do is going to work. But if you put in print addition, it will give you an exact answer and also what you type in inside of the double quotation with the print function. Okay? So the next thing that we're going to learn about is variable assignment and also reuse. Now, the step that I'm going to be showing you is basically going to be using variables into calculation, such as let's create a variable. Let's type in length. Length is equal to 8.
and width is going to be equal to 4 in this case. Now let's say the area of anything is length into width. So you can type in area equal length into width. Make sure all of them are the same text. Then type in print, let's say area of rectangle colon double quotation comma area. Close off the parentheses and hit on shift enter, and you can see the area of rectangle is 32. You can also put in centimeter or inches or whatever you want to put in the unit. It will still give you the specific answer. Okay, now let's move on to the next one. The next thing that we're going to learn about is creating or defining a list. If you've seen my previous class, then you already know about it. So first off, let's put in number equal. Now, whenever you are creating or defining a list, you have to put in secondary bracket. In that case, secondary bracket 2, comma 4, comma 6, comma 8, comma 10. In this case, I'm going to be keeping just like this. And then what you want to do is you have to print out, or you can put in print, open parentheses, and put the exact same name, put in number, close off the parentheses, shift enter, and you will see the exact numbers will be represented on the list answer. Okay, you can also do the same thing with string values. Let's say print, or else I'm going to put in fruit equal secondary bracket, double quotation, apple, comma, big, comma, cherry. You can put in whatever you want and close off the secondary bracket. Hit on enter. I'm going to put in print, open parentheses, define in fruit, shift enter, and you can see now you have defined in, the apples, the cherry, the fig, or let's say the fruit names. So in this way, you'll be able to get values like this too. It doesn't matter of what value it is still going to show you the answer. You can put in 2.23, shift enter, and it is still going to give you the float value in the same time. Now, another thing you can see, I can put in single quotation. If I put in that, you can see the single quotation is also going to be visible. That means if you're using string values for creating a list, you can put in both double quotation and also the single quotation at the same time. Now, whatever you put, the quotation is still going to be visible when you want to print them out one by one. Okay? You can also use index value, such as you can put in fruit, then put in 0, and close off, and you can see now it is showing me apple. So this is how you'll be able to print out, or let's say define a list like value, and also print out the whole list in the same time. Now, let's go and iterate through a list. So simple for loop. What you can do is you can put in for num in number. You can see we have already number. Now I'm going to put in a colon, hit on enter, and put in print num. Now you also have to put in this num on, a parentheses, hit on enter, and now you will see everything will be on a line, and you can see there is no quotation inside, or let's say before and after the number. In this way, you'll be able to print it out without the quotation and line by line, also without the secondary bracket. So you're going to use print number, or let's say print and then the variable when you want to print it out just like this in a whole list. But if you want to print it out without the quotation and also line by line, then obviously use the for function and iterate through a specific list. If you want to add one to each item, then put in for num in number colon, then type in print, open parentheses, num plus 1. Close off the parentheses, shift and enter, and everything will be added up with 1. You can also put in subtraction. Let's say I'm going to put in for num in number colon, then type in print, open parentheses, type in num minus 1, hit on shift enter, and everything will be minused by 1 or whatever there is in the specific list. So this is how simple it is to also use list iteration, simple for loop, and even add 1 to each item and also subtract with each item. Now you'll also be able to multiply each item and also divide it in the same way. So let's say for num in number colon, type in print, open parentheses, num. Now multiply it with 2. Hit on shift enter and everything will be multiplied by 2 in the same way. Now, the next thing that we're going to learn about is storing iteration result in a specific new list. Let's say what I want to do is, first off, you have to type in doubled, which is the specific variable, secondary bracket, and keep it empty because we're going to be showing that in another cell. So let's say I'm going to put in for num in number colon, then type in doubled dot append, open parentheses, num asterisk 2, close off the parentheses, then type in, let's say, print, open parentheses, type in doubled list, colon, double quotation, comma, and then type in doubled. Shift and enter, and you can see we have the doubled list 4,46, and you can see we have another list saved up on this cell. So this is basically how you'll be able to show the result. Now what you can do is you can also apply one-liner list iteration. If you want to do that, it is also quite simple. Let's say in this case, I'm going to put in doubled equals secondary brackets, put in num asterisk 2 for num in number, close off the secondary bracket. I'm going to put in print, put in doubled, close off the parentheses and hit on shift enter. And you can see this is how it is going to show off. So this is how you're going to do one line iteration, or let's say one line list iteration. And this is how you'll be able to do store result and also new list iteration. Okay, so this is how simple it is to work with calculation and list iteration for data analysis with Python. So there are also a couple of tips to make it effective in Jupyter. First off, you have to make sure to break down codes into small cells. Such as you can see in a couple of these things, I have, done it in different cells. It makes it more easier for Python to understand. It's not like if I put all of them together, it will not understand. But sometimes you might face a couple of errors and make it more complex for Python to actually give out the exact result. In that way, what you have to make sure is you break down the code into small cells. In that way, it is going to be a bit more organized and also more effective. You have to use Markdown cells to explain which or what each step does. So if you want to do markup cell, what you can do is you can insert a cell above and also up. And you can also do is create a duplicate of the cell in the same way. You can also mark them up in the same way. This is how it will look like. You can see you'll be able to mark it down step by step. You can also select them one by one. Okay, so this is how it is going to look like. You can also make sure you put it out like this. In this way, you will get an answer and you'll be able to mark down which one you are working with. Okay, so what you can do is on the answers, I can mark it up like this. We have the answer of this one. If I put it down like this, it is the exact answer. This is the exact answer. This is the exact answer. And this is also the answer that I can see. This one's also the answer. So basically, this is how you're going to mark down. So it is just a bit more easier to see. There we go. Okay, so this is how simple it is. Now, another thing that we have to know about is using print statement to show output clearly. In most cases, we have used the print function, which basically prints out the exact data. And this is the most simple one for Python to understand. So I would suggest you, whatever you do, even though I've shown you about these ones, but I would obviously suggest you that type in print and then give out the answers a bit more easily, which is going to show you a clear output. In some cases, without using the print, it is not going to give you an answer because it just doesn't work in some cases. So make sure to use the print function, which shows the output clearly. And obviously use the comment inside the code for clarity. You can use the comment, which is basically using the hash. Now this hash is mostly in cases of, clearing out the clarity. In this case, what I can do is, let's say, this one. Now, obviously, this one has a specific comment. Let's say I can put in hash comment, or else I'm going to put in hash subtraction. You can put it just like this, so there is a bit of clarity in between. Okay. Now for this one, what I can do is I can, close off the line, put in hash multiplication. In this way, I'll be able to see more clarity and what function I am doing or whatever actions I am doing. Okay. So now you know everything about calculation and list iteration. So that is basically it. So thank you for watching this class up till the very end and hope you understood about everything in this class. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of data analysis with Python. Welcome to a new class of data analysis with Python. In this class, I'm going to be showing you the introduction to pandas and data frame and the basic commands of pandas and data frame and how to read CSV. So first off, before getting into the practical part of this class, we have to know about what pandas is and what is data frame. So pandas is a robust Python package for data analysis, manipulation, which is called pandas. There are two primary data structures which are offered by it: series and data frame. Series are a labeled array in one dimension, or let's say one line, and data frame are labeled two-dimensional data structures similar to a spreadsheet or table. So data frame could be of different cells and also a lot of cells in the same time with rows and columns, but series are basically either columns or either rows. So what is data frame? A data frame is comparable to an SQL table or Excel sheet. It features labeled rows and columns and a list of data. So now that we know about pandas and data frame, so let's get into our class by opening up Jupyter Notebook on our device. Now, obviously, there's going to be a lot of things that I'm going to be showing you in this class, and that is going to be also part of the basics. So make sure not to skip any part because it is going to be very important for you. First off, let's click on New and click on IP kernel. Let's close this off, or you can also name it right over here. Let's say I'm going to put in pandas and put in data frame. Now we have renamed it directly from Jupyter Notebook and after opening up the file. The first thing that you need to know is you have to import pandas. Let's say I'm going to type in, just click on the cell, import pandas. Now that's basically all that you need to do. Okay, this is the first cell. Now the next thing is reading the CSV file. Now you're also going to need a CSV file that is going to be important. Now you can see that I have already applied in a CSV file, which is sample data frame. But if you don't want to use that, it is totally fine. There are also a couple of sites where you'll be able to get CSV files, such as you can go to data.gov, Google Datasets like search, and you can also use Macaru. Now, most of the time I use Macaru. Basically, this site generates custom CSV files. So I'm going to click on that and we're going to wait for a bit until we have this. Now from here, I'm going to click on generate data. Now in this way, the data file has been opened. And what we can do is we can open up the exact folder and we're going to keep it on the exact folder where our CSV file is, or let's say where our notebook is opened up. So I'm going to click on show in folder. I'm going to press on Control X. And then I'm going to go off into data analysis, new folder, and I'm going to paste it right over here. So we have mockdata.csv, and we also have sample data frame.csv. Another thing that you can do is you can create your own CSV file. You can right click, click on new. Let's click on text document. Let's open it up first. Let's say I'm going to put in name, put in comma, let's say age, comma, city. Now here I'm going to put in Alice, comma, 25, comma, let's put in New York. I'm going to put in Bob, comma, let's say 50, comma, Los Angeles. Then I can put in Charles, comma, 24, comma, Chicago. So in this way, you'll be able to create your own CSV file, but it is still not saved. So what I can do is, first off, I can save it up. I'm going to close it off. Then what I'm going to do is I'm going to rename it. First off, what I'm going to put in is I'm going to put in example, and on the TXT format, I'm just going to type in CSV. Hit on yes, and this will turn into CSV. Another thing that you need to know is how you can change the format. First off, go on to view and click on file name extension. When you click on that, you will see the extension will also be visible. In that way, you'll be able to create more CSV files. Now let's head back into our folder, or let's just head back into Jupyter Notebook. Now, the first thing that you want to do is you want to open up the exact data set, or let's say the CSV file. So first things first, type in df equal, then put in pd dot read underscore CSV. Open up the parentheses, put in single quotation. Now, after that, we're going to have a lot of these files. Okay, so what I can do is I can put this mockdata.csv. So put in mock underscore data.csv. Single quotation to close it off, and that's basically all that you need to do. Hit on Shift Enter, and you can see sometimes it might show you off as an errors because we did not put pandas as PD. There we go. We have freed up the data. Now, if it is on a different folder, it is also totally fine. I'm going to open up the folder again. Now, let's take up this example.csv in our folder. I'm going to open up this folder and I'm going to paste it right over here. It is totally fine. Let's go back into this over here. And what I'm going to do is, if it is on a different folder, type in df equal pd dot read underscore CSV, open up parentheses, single quotation, then define in the exact path. Okay, so if it is the exact path, you have to open up the folder again. Let's open up this. Let's copy this up, Control C. Let's go back over here. Then here, after CSV, single quotation, define in the path, then put in slash, and then put in the exact data, such as example.csv. Close off and hit on Shift Enter, and you can see there is still no data over here, and you can see unterminated string literated. In that case, it is also totally fine. So what you can do is I'm going to put in Python, and then you have to put it just like this. Okay. Now, another thing you can see, it is still not detected, so it is totally fine. Let's take this, Control X. Let's open up another folder. Let's press on New, another folder, New folder. I'm going to paste it right over here. Now, I'm going to do is I'm going to create this. Okay. Control C, go back, and then you want to paste in the exact folder. Now we have that just like this. So I'm going to make sure to cut this off. And if it still doesn't open up, it is also totally fine. Let's close up this line. Shift on here. You have new folder 2 times. So let's put in, let's say, example.csv. Now we have the single quotation that is starting off, but it is still not working. It's because sometimes it cannot detect of the exact file. Well, let's just put in // and hit on Enter, and you can see it is still not being detected. If it doesn't work for you, it is also totally fine, because there is an unterminated string literation or literal detected at line 1. Okay, so this is the exact thing that is being not detectable. So it is totally fine. If it doesn't work for you, you can just stick to the first method. And what you can do is you can just keep it up in the exact folder and work along with it. So I'm going to do is I'm going to Control X and I'm going to paste it on this exact folder so it is working a bit better. Okay. Now let's just move on to this part. If you want to display the data, let's say you want to show the first 5 rows, put in df dot head. Open and close off the parentheses, hit on Shift Enter, and you will see the first 5 lines will appear up with the first name, ID name, last name, email, gender, and also the IP address. There are also some extra tips that I want to show you. If the file has a different delimiter, such as semicolon, or even a different encoding, you'll be able to open up in different ways. Such as if it is on a semicolon, then put in df equal pd dot read underscore csv, open up the parentheses, colon, let's say mock underscore data dot csv, single quotation, put in comma, delimiter, equal, single quotation, and then put in semicolon. In that way, if it is, differentiated by a semicolon, it will be, like applicable. But if it is not going to work. Just like this, it is going to show you off as an error. As we don't have a delimiter, it is totally fine. Now, if you have another file with different encoding, it is also quite simple. Let's say I'm going to have it just like this, and after the comma, put in encoding. After encoding, put in equal, and then what you want to do is you want to put in the UTF-8. UTF, put in -8. And that way, it will use up any of the encoding used by UTF-8, and it's going to show you in Latin 1 ISO 8859, which is also a specific ISO. And you can see that we have got this from, the web. So obviously this is UTF-8 from a browser, and that is why it is working properly. And you will also be able to use sample CSV files for specific practices. Okay. And we also have the example.csv file on our, exact folder where we are running it. Now, the first thing that we want to do is we want to open up the another file, which is the example file. So I'm going to put in df equal pd dot read underscore csv. Open up the parentheses, and here I'm going to put in, let's say, example.csv. Single quotation, close off the parentheses, and hit on Shift Enter. Now, there are a couple of ways to explore the data, such as I've already shown you df.head, open close parentheses. It shows you off the head. Now, it is going to show you basically 5 heads or 5 data, but it is totally fine because we do not have 5 of these data. Now, you can also use the mock data. In that way, you'll also be able to work with it. So here I can put in mock underscore data.csv. There we go. We have Dimitri, Kurt, Rennie, Joanna, Sherlyn, and also all of their last name, email, gender, and IP address. If you want the last 5 rows, you can put in df.tail, open close parentheses, hit on Shift Enter. And there we go. We have the last names, such as the ID is 996, and also the first name Octavius Bear, the email, gender, and also the IP address. You'll also be able to, make markdowns to check it out if it is working properly. Then what you can do is you can also see the rows and columns. First off, you have to put in df.shape, and you will see that there are 1,000 rows and 6 columns. So 1, 2, 3, 4, 5, 6. So 6 columns, and also up to 1,000 rows. Okay. Now, the next thing that you want is a summary of the data frame. If you want the summary of the data frame, you have to type in df.info. Close off the parentheses, hit on Shift Enter, and you can see this is how it looks like. So yeah, I'm going to put in df, and there we go. So you can see, let's say, the summary of it is class pandas frame.dataframe. Range index is 1,000 entries and 0 to 999. We have the data columns, total 6 columns. We have the column categories as ID, first name, last name, email, gender, IP address. We also have the non-null count. So all of them are non-null. So every one of them has specific values. And the D types are integer 64 and also object. Okay. And the memory usage is also 47.0 plus or minus KB. That means this is a very small file. Now, the next thing that I want to show is the statistical summary. If you want the statistical summary of the data frame, type in df.describe. Open and close off the parentheses and hit on Shift Enter. And there we go. We have the count, which is 1000. Mean value is 500. Standard value is 288.819426. Minimum value is 1.0. Then 25% is 250, 50% is 500, 75% is 750, and the maximum value is 1000. So in this way, you'll be able to get all of these, statistical summaries of the data frame. Now, the next thing that you want to do is selecting the columns and rows. If you want to select a single column, what you basically have to do is type in df. And now every one of these datas or the column or rows are basically arrays, right? Or lists. In that case, put in the secondary bracket, single quotation, let's say column underscore name. Single quotation and close off the secondary bracket. Hit on Shift Enter, and you can see this is how it might look like. Well, it is totally fine because you can see the engine getLog casted a key. So we have df, secondary bracket, single quotation, column, name. Now what I can do over here, we can get a column name from here. Let's say the first name. Let's say here I want the first name. Now, if I put in first name, you will see the first name is Dimitri, Kurt, Rennie, Joanna, and then Octavius, and so on. And the length is 1000. So this is basically how you are going to get the exact column. If you want a different one, it is also totally fine. Let's say maybe I want the email. So if I put in email over here, it is going to show me all of the emails starting from 0 to 5 and then the last ones. It is not going to be able to show you 1000 of them. So in that case, the first 5 and the last 5. Now, the next thing is that how you're going to select multiple columns. If you want to select multiple columns, put in df, 2 secondary brackets to open it up. Let's say column 1, and then you're going to put in comma, and then comma, column 2. Let's close it off the quotation and close off the secondary brackets. It might show you off as an error, but it's totally fine. Let's say on this one, maybe I want the last name underscore name, and column 2 that I want is the gender. So here I'm going to put in gender. Shift Enter, and you can see Moy, Lane, Maddle, Hemsworth, Skippings, Crocum, we have Bear, Grimsley, Busquet, Nestor, Butch, and also so on. And it's also showing me the gender. If you want more, you can also put in more. Let's say single quotation, first underscore name, single quotation, and it will also show you the first name. You can also get in the email if you want to. You can put in single, let's say single quotation, email, hit on enter, and it is also going to show us the exact, email too. But one thing you have to keep in mind, if you want multiple columns, then you just basically have to put in 2 of these secondary bracket or squared bracket to show it better. Now, the next thing that I want to show you is rowing by index. Okay, if you want to do that, first off you have to do is put in df dot ilog, secondary bracket, and put in 0 as the index, hit on Shift Enter. In that way, everything on the row 1 or the first row will be appearing over here. Let's say this is how it works. You can also put in 1, Shift Enter, and it was going to show you the second one. You can see Kurt, Maddle. Then if you want the third one or second one, it is going to show you the third and also the categories in the same way. And you can see the D types are object. If I put in tree, it's going to show you object and also the fourth value. Now, the next thing that you can do is you can do like label based. If you want to do it label based, you have to put in df dot loc location and put in 0 if you want to. Now you can see we have the name 0, D type is object. Okay, you can also put in 1 if you want to, and this is how it is going to look like. Now, the next thing that we're going to learn is basically about filtering the rows. Filtering the rows is also quite simple to do. Okay, so first things first, what you have to put in is you have to put in df, secondary bracket, and define in df again. Secondary bracket again, single quotation, let's say I want to filter the rows. Let's say if you put in age, there is no such thing as age. Another thing that I want to do is, let's say I want to put in the ID. So here I'm going to put in ID, say like single quotation, and here I'm going to close off the secondary bracket, greater than 25. Secondary bracket, and it is going to filter the rows greater than 25. So there we go. We have after 25, it is 26. We have Sibley, Scarterfield, and all of them, so on. So everything after 25 will be visible. If I want it after 900, it is also going to show me after 900. Okay? So you'll be able to filter rows and columns in the same way. Now, if you want to use multiple conditions, you can put it in the same way. First off, I'm going to copy this, Control C, Control V over here. Now, after that, you can see after 900, I'm going to make sure that I open and close it off with a parentheses. So after the df, open up the parentheses, and here I'm going to close it off with the parentheses right over here. I'm going to put in ampersand, open up the parentheses again, put in df, secondary bracket, single quotation. Let's say the next thing that I want to use is basically going to be, let's say, a specific IP address, or let's say the gender. So here I'm going to put in gender over here, close it off, single quotation, secondary brackets, double equal to, let's say I want all the male values. So here I'm going to put in male. So every one of the male values will appear over here. Secondary brackets, close it off, and hit on Shift Enter. So every one of those values that meet up the criteria after 900, and all of them which are male, is only going to be visible over here. If you want only female, then I can also put in female. And all of the ones after 900, every one of the females will appear on my screen. So you can see you'll be able to use multiple conditions in the same way. You can also add and modify columns. Let's say, first thing that I want to do is, let's say I'm going to put it over here. First off, df, secondary brackets, single quotation, let's say new Paul. Close off the secondary brackets, put an equal, df. Here I'm going to open up the secondary brackets. Here I want to put in, let's say, the gender. Or I can put in age. What I'm going to do is I'm going to plus it with 2. It might show you off as an error because there is no specific age. But what I can do is I can put in gender. You can see it is still not working up because there is no df and there is no specific values as gender, which it should multiply. So what I can do, here I can put in ID. I can see it is going to show me, and it's going to apply a new column with ID adding up 2. If you want to update the column, let's say what I have to do over here, so I have to put in df, secondary bracket, single quotation, let's say ID, close off the secondary bracket, put in equal, df, secondary bracket over here, single quotation, ID, close it off with this another secondary bracket. And what I want to do is I want to multiply it, so put in asterisk and 2, which is going to update the column. In that way, if you want to print out the ID, you will see 2 more applied. Okay? Now, the next thing that we're going to learn is about dropping columns and rows. If you want to drop the column, first off, you have to put in df.drop. Open up the parentheses and put in single quotation. Let's just put in a column name. Now, the column name that we want to use is the first name. Okay? Or let's say I want to put in, okay, let's just work with first name. First underscore name. Now I'm going to make sure to put in a comma. It is axis equal 1. Put in comma. I'm going to put in place equal true. This is how it's going to work. Close off the parentheses and it's going to drop off the column. Okay. Now the next thing that you can do is you can put in df drop to draw row by index. You can put in df dot drop, then open up the parentheses, put in 0, comma, axis equal 0, comma, and in place equal true. I can see we have 0 over here, unexpected error. I'm going to put in place. Now you can see it is working up properly. Okay, so this is basically how it is going to work. Now if I copy this and if I paste it again, you can see it is reading up the data. Another thing that I can do over here is I want to apply this DFN. So I'm going to just copy and paste it over here and on enter, and you can see the first indexes have been cut off. But you can see it is still reading up the data. If I cut this off, and if I remove this, and if I put in shift and enter, you can see it is still showing me the exact same thing. Okay, so this is basically how it is going to work. Now, the next thing is sorting and also the values. If you want to sort the values, it is also quite simple. First off, I can put in df dot sort underscore values, open up the parentheses, single quotation. Let's say I'm going to put in the gender. Put in gender, single quotation, comma, ascending, equal true. Close off the parentheses and hit on shift enter. And you can see we have the agender, polygender, and so on. So these ones have been added in the gender, multiplied by 2, and also added by 2. So you can see this is how it is going to work. Okay, so these are the ones that has been added, and this is how it looks like. Okay, now the next thing that I want to work with is check or handle the missing data. If you want to count of missing values, whenever you are doing with it, you can put in df dot is null, even though we don't have any null values. So open up the parentheses, and then you have to put in sum and open and close off the parentheses. It is going to count for missing values. So you can see ID 0, first name 0, last name 0, and integer is 64. Now what you can do is you can drop rows with missing data. You can put in df dot drop na, open the parentheses, type in place equal true. In that way, it is going to show you off with missing data, but we don't have any, so it is not going to work. If there is a missing value with 0, you have to put in df dot fill na, then open up the parentheses, start off with the 0 index, comma, in place equal true. Enter. And if there is any 0 values, it is going to just basically fill up the missing value with specific 0. Okay, so this is exactly how it is going to work. If you want to export to CSV, you can also do that. Let's say I'm going to put in df dot to underscore CSV. Then after that, I'm going to close it off with single quotation or single underscore. Open up the parentheses, now put in the name of this file, let's say output.csv. So we have the output like .csv as the name, and then put in comma, and then I'm going to put in index equal false. Close off the parentheses and hit on shift enter, and that file will be exported. Okay, so if we open up the file, refresh it, now you will basically have an output.csv file right over here. It is 62 KB, but this one you can see we have the mockdata.csv, which is also 61. This is modified and this is not. So this is basically how you are going to work with CSV files and also work with data frames. You can also apply subfolders and so on, and you can keep all the things or the CSV in the same folder, which makes it a bit more interesting and also simple to access. So thank you for watching this video up till the very end, and hope you understood about everything in this class. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. Another thing that you want to do is let's just open up this file And we have something called, let's say, CSV over here, sample data.csv. You can copy this. Let's say I'm going to copy the whole thing, Control C. If you want to open up this file, do the same thing, df, then put in the exact same df equal, put in pd dot read underscore CSV, open up the parentheses, single quotation, and paste it out. And then close off the parentheses and hit on Shift Enter. And this is how it is going to work. If you want to read out the data, you just have to put in df.head. And there we go. You have the name, age, city score, and also so on. So this is basically how you're going to create your data frame. If you don't have any, you can also generate more datas if you want to. And then you just basically have to put in the exact commands that I have shown you in this class. So thank you again. And without any further ado, just keep on practicing and do not skip any part because it will help you in this whole course. So let's move on to our next class of data frame with Python.
Welcome to a new class of data analysis with Python. In my previous classes, I've shown you about basic code snippets that you are going to use to manipulate and also access data forms from specific CSV files. So in this class, I'm going to help you to load and explore a simple data set, an example, Titanic or Iris. Now, both of these data sets are going to be used, and I'm going to be showing you how you'll be able to open up both of them, and also how you're going to explore the data sets. Exploring the data sets is going to help you to seek onto those data sets and check out your specific data that you need, and you can also find them out step by step by using the previous things or the previous code snippets that I've shown you in my previous classes. So, without any further ado, let's move on to this class by opening up Jupyter Notebook on our device. As you can see from my screen, I have opened up Jupyter Notebook. Here, I'm going to click on New, and I'm going to create a new file. And let's say I'm going to name it Iris. Okay, so first things first, this class is perfect for beginners to get started with data analysis. So there are dataset options, such as the Titanic and Iris. Obviously, these are not just two data sets that you'll be able to use in the whole course. In my previous class, I've shown you how you'll be able to also use specific CSV files that you download online. Okay, so first things first is that Titanic dataset is going to contain all the data about passengers on the Titanic, which is used for classification and also survival prediction. And the Iris dataset is the measurement of iris flower used for classification, flower species prediction. So first things first, if you want to go for something clean and small for simplicity, then you can go for Iris dataset. Now, first things first that you need to do is you have to import required libraries by Python, such as I'm going to import pandas as PD. I'm going to import Seaborn as SNS, and then I'm going to import matplotlib.pyplot as PLT. Hit on Shift Enter, and you can see that this one has been done. Now, if it shows you off as an error as matplotlib, you can see Seaborn as SNS. You can see Seaborn as SNS, no module name Seaborn has been found. Now, if it doesn't work, it is totally fine. First things first that you want to do, let's just cut this off and let's paste it over here. Control X, Control V. Let's just keep it over here, and we're going to install Seaborn. Type in pip, type in install, and type in Seaborn. Shift Enter, and it's going to take a bit of time to install all of the dependencies, and then you'll be able to run Seaborn, and then you will see there you will not see any specific errors. Okay, so after we're done,
what we want to do is we want to load the iris dataset. So to load the iris dataset from Seaborn's built-in dataset, type in iris. Type in equal SNS dot load underscore dataset. Now you will see that it has run perfectly. Now type in iris SNS dot load dataset and then open up the parentheses to put in the controller, type in iris. Close it off and close off the parentheses and hit on Shift Enter. Now after that, you want to display the first five rows. Now in my previous class, I've shown you for the first five rows, you have to put in head, and for the last five rows, you have to put in tail. So type in iris as the controller, type in dot, head, open and close parentheses, and hit on Shift Enter. And you will see that the sepal length, the sepal width, the petal length, petal width, and also the species. Okay, so this is basically how you're going to load the dataset, such as the SNS.load dataset pulls the dataset into validation. And when you put in the head, it shows the first few rows to get a feel for the specific data. Now, let's get into the basic info and also the summary. If you've seen my previous class properly, then it would be very simple for you. First off, you have to put in, or you have to make sure to check the dataset or check the shape of the dataset. So type in print, then put in double quotation, type in shape, colon, quotation close, comma, put in iris dot shape. Close off the parentheses and hit on Shift Enter. In that way, you will see the shape of it is 150 into 5. So 150 rows and 5 columns. This is how it is. We can see 1, 2, 3, 4, 5. That means we have 5 columns and 150 rows of these data. Now, let's learn how to get data types and non-null info. For that, you have to type in the controller iris, then type in info. In that way, you'll be able to get data and also non-null values. You can see the usage is 6 KB or plus KB. We have total columns 5, non-null 150 non-null. We have D types, which is float 64, and also the object. You can see why it is float 64 is because most of them has, let's say decimal values. If it didn't have any decimal values, then it would have shown such as something like, numeral or something like that. Okay, so this is how it is, and this is the info. And obviously, if you want the summary of these statistics, you have to make sure to put in the function called describe. So type in iris dot describe. Now open and close off the parentheses and hit on Shift Enter. In that way, you will see the count value, the mean value, the standard value, the minimum value, 25%, 5%, and also 75%, and also the maximum percent of the whole row. Okay, so basically, when you put in the function called shape, or you define in shape, but while using a controller, it basically gives you out the rows into columns. That means the whole shape and the whole size of how many columns and rows are being used in a specific data set. When you use the info function, it basically sets up the data types and also the missing values. And as you can see, there are no missing values in the data set. That is why you can see there is 150 non-null value. And we obviously have 150 like rows. Okay. Now the last one is describe. When you put in describe, it gives you off the count value, the mean value, standard value, minimum value, percentage of it, and also the maximum value at the same time. So the describe is quite helpful in a couple of cases. Now, the next one or the next function that we're going to apply is checking for missing values, which is null. So let's type in iris, then type in is null. Open and close off the parentheses and put in sum. In that way, it is basically checking for null values, and this tells us if we need to clean the data. Hit on Shift Enter, and you can see the sepal length is 0, sepal width is 0, and all of these are basically the 0 count. So you can see obviously the first ones are going to be 0, and these are the values that we need to clean the data from. Now, The next thing is exploring the visualization. Now, exploring visualization is quite helpful in a lot of cases, such as you need visual presentation in a lot of cases, such as in relationship and also in correlation heat map. Well, those are also kind of like, specific classes that I can show you. But as this is a beginner friendly class, I'm going to be showing that to you in more simple way. First things first, you have to make sure cplot, or let's say Seaborn and also matplotlib is installed perfectly. If it shows you off as an error, make sure to install it in the same way I have installed Seaborn on my device. But if you have Python installed on your device, then obviously it is going to be there with the directory file. And also, if you followed up my class and put your Python and its script file into the environment variables, then also it is going to work. Okay, first things first, let's explore the visualization with pair plot to see the relationship. So here, first off, you're going to type in SNS to put in, or let's say to import Seaborn, and then type in pair, type in plot. After that, open up the parentheses. You have to define in the controller, such as iris, comma, then put in hue equal single quotation, type in species, single quotation to close it off, and close off the parentheses. Now, in the same way, how we use Python show, let's say something like py.show. Here, I'm going to put in plt because we're going to be showing pair plot using SNS. So type in plt.show. But it is also going to use matplotlib. As you can see, we have plt. Then wait for a bit, and it will show you off the diagram and also all of the relationship with the visualization. You can see we have the sepal length, all of these over here. We have the petal width, we have the petal length, the sepal width, the sepal length, we have the petal width, petal length, sepal width, and also so on. Okay, we have the setosa, versicolor, and we have virginica. Okay, so all of these are going to show you of the plot and how it basically is going to show up. Now, this visualization is very important in a couple of presentation cases and also for research purposes. Okay, it gives you off a better idea about how these are and what are the statistics, and also you will get the info at the same time. Okay, now the next thing that we want to do is we have to know about the correlation of heat map. So obviously, if you have Seaborn and also matplotlib install, then it is going to work. First off, what we want to do is we want to type in sns.heatmap. Now, after that, open up the parentheses, type in iris.corr, type into correlation, open and close off the parentheses, comma. Now, the next thing that you want to do is basically a Boolean value. You have to make sure to put in anot. Type in true, comma, and then put in the CMap, put in equal, single quotation. Let's say I want cool, warm. There are a couple of, different ones that you'll be able to use, but I'm going to be using cool, warm. Let's say I'm going to put in plt dot show, open and close off the parentheses, and shift enter. Now you will see sometimes it might show you off as a couple of errors, but it is totally fine. Make sure you put in the heatmap.iris, then put in correlation, and then open and close off the parentheses. First thing you can see, we have SNS iris correlation and anot CMap cool warm. Then there it is that the error is data to numpy. We have the d type as float. Okay, so as we have float values, sometimes it might not work properly. Okay, if it shows you off error like this, it happens mainly because you're trying to calculate the correlation on a data frame that includes non-numeric data, specifically the species column, which contains strings like setosa. So basically, when you are using this CORR correlation, this method only works on numeric columns. But inside of this whole array of data, we also have the species. Okay, so basically what we have to do is we have to exclude the species column, and we're only going to validate the numerical. First off, what we want to do is we're going to put in numerical, or let's say I'm going to put in numeric data equal, let's say, iris dot select. Then after that, you have to put in the types. Okay, open parentheses. I'm going to type in include. Then after that, put in equal. Then put in single quotation, define in number. Close off the parentheses. Now the next thing that we're going to do is basically we're going to run the plot with the heat map. Okay, so copy this and paste it and hit on Shift Enter. Now you can see sometimes it might show you off as an error because we did not close off this quotation. And you can see this is still showing me off as an error. It's because sometimes it cannot find the plot. So here, instead of using the exact same data of iris correlation, you have to type in numeric data. So let's change it. Numeric data, like exactly how you put it. Now here, you're going to put in correlation, then put in not equal true, CMAP is equal to colon. And there we go. You will find that this is how it is going to work. Let's just remove this so I can keep this only line. So you can see we have the petal length, the sepal width, and also so on whatever data that you need. And also we have the heat map of 1.0 to 0.4. Okay. You'll also be able to customize it. You can select, click to add cell. You'll be able to add cell from here, but you'll also be able to add more cells from here too. Okay. So basically, when you put in D types or select D types, include number, it selects only columns with numeric types, okay, or numeric data types. It's going to exclude everything that, has string values or any other values. So that prevents error from correlation, which tries to compute correlations. Okay. Now, the next thing that we're going to learn about in the iris dataset is basically how you are going to group by the species, because there's like a lot of species. If you go off over here, you can see we have species. Now there's maybe like 3 or 4 types of species, but we don't exactly know. Okay, so here what you can do is you can type in iris dot group by, then put in open parentheses, single quotation, species, single quotation, and close it off. Close off the parentheses, put in dot mean value, open and close off the parentheses. Now hit on Shift Enter, and you will see that there are 3 types of species: Setosa, versicolor, and virginica. Okay, so this is great for comparing flower types, which are the 3 over here. So basically in the summary, we can see that we have imported libraries, which are tools to analyze and plot. We have the loading dataset, which loads up the iris datasets. We also used the basic info and summary to understand the structure and the statistics. So as we are done with almost all of the actions that we did with this specific dataset, now let's get into the summary. In the first step, we have done is import the libraries. The purpose of it is for the tools to analyze and plot this dataset. In the second step, we loaded the dataset, which helped us to load the iris dataset into validation and also into this specific file. In the third step, what we did is we got the basic info and summary, which helped us to understand the structure and the statistics of the data. Then in the fourth step, what we did is we checked for missing values, which helps us to clean data if it is needed. Then we learned about visualization, which is in the fifth step, which understands the patterns with specific plots. Then we learned about group and summarizing, which helped us to compare across categories. So all of these data and all of these action together is basically going to help you to do whatever you want with your data set and accessing your data. Okay, so as we're done with the iris, now let's create another file. Click on new and IP, like Python 3 IP kernel. Let's name this Titanic. Now, if you don't have the Titanic file, it is totally fine. But first off, let's get into an import, or let's say load up our SNS. So type in import Seaborn as SNS. And what we want to do is we're going to type in Titanic, type in equal SNS.load underscore Dataset, open up the parentheses, type in Titanic. Close off the parentheses, hit on enter. Now we're going to wait for a bit if it is not validated, because sometimes Titanic dataset is not loaded up with Seaborn or even Matplotlib. So here, what I can do over here is I can type in Titanic, then put in .head. If it shows you off, or if it shows me this, then it means that it has loaded perfectly. And if you don't see, or if you see an error that Titanic file is not located, then open up a new tab and type in download Titanic dataset. Hit on enter, and you can see you can go off to GitHub. Now from this file, what you want to do is just click on download raw file. Then after you download the raw file, you just want to take this exact file, and then you want to go off directly into your folder and then paste it in the exact same folder where you have Jupyter Notebook like placed. Okay? In this way, Jupyter Notebook will, identify the Titanic CSV file, and you'll be able to work according with it. Okay? In the same way, you will be able to do the same thing, such as if I put in titanic.info, it will give me the info. If I put in titanic.describe, it is going to help me to describe it. We can see survived are 821%, and the mean value is 0.38, standard value 0.48, minimum 0, 25 is 0, 50% also 0, 75% is 1, and maximum percent is also 1. That means only 75% to 100% people, like among them, survived. Okay? But from 50%, or let's say up to 74% people died. Okay? So this is basically how you'll be able to, extract the data. You'll be able to work along with it. If you want to group by specific, class, you can also do that. Let's say I can put in Titanic dot group by, and you can type in open parentheses. Let's say I want to put in survived, close off, then close off the parentheses, type in dot mean value, and wait for a bit, and then it might show you off something like this. If it doesn't show you off that the grouper AGG series sort alt D type is true, that means you also have to make sure to put in the value where you have to make sure you have to put in the correlation first, and then you are going to be able to get this exact data. Okay, so there we go. That is the exact person, how like many people have survived. And you can put in the specific age in the same time. Let's say if I try putting in age, let's see if it works. There we go. It is still showing me as an error because there is a float type which is working as false. So basically what you have to do is, first off, you're going to make sure you put in a numeric data set. You have to select the D types, include numbers, and then you're going to put in the specific value. Okay? So to make it more simple, first off, you want to type in, let's just do it over here. We have import Seaborn. Let's also import pandas as PD, and also import matplotlib dot pyplot. And that way everything is now validated. We can try hitting on enter. If it doesn't work, it is totally fine. Now you'll be able to get the shape of the data. You'll be able to check for missing values. In that case, first off, let's check for missing values. I'm going to put in Titanic, then put in dot is null dot sum. There we go. We have a couple of these data sets, which is basically how it is going to work. Then you can put in, let's say you can drop unnecessary columns. Let's say I can put in Titanic underscore clean equal Titanic dot drop. Then open up the parentheses, columns equal secondary bracket, as these are arrays. Let's say I'm going to put in deck, comma, single quotation, put in embark underscore town, single quotation, comma, single quotation alive. Close off the secondary brackets, and you can hit on enter, but close off the parentheses. And in this way, this is basically how it is going to work. Now, another thing you can see, it is showing me another error. So obviously there's another fix to it. Now here, I'm going to change this to town, which is a typo. And there we go. So basically 3 columns will be dropped. Now, if you want to group by, summarized, or, you want to group specific, summary, what you have to do is type in Titanic dot group by, and now there are like a couple of, string values over here. So I'm going to put in, let's say, survived, close off the parentheses. I'm going to put it up by age, comma, I'm going to put in fair. Then close off the secondary bracket 2 times, as you can see. I'm going to make sure to put in another secondary bracket to open it up over here. And then I'm going to put in dot mean value, open and close off the parentheses, and hit on Shift Enter. And you can see the age 30, and we have 22, and we also have 28.34. So in the same way, you'll be able to use all of these data sets to get into specific actions, and also you'll be able to summarize with specific needs. So thank you for watching this video up to the very end, and hope you understood about everything in this class. If you have any question or any confusion, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of data analysis with Python. Welcome to a new class of data analysis with Python. In my previous classes, I've shown you everything or most of the basics that you need to know about data analysis. So in this class, I'm going to be showing you a very simple thing that you are going to be doing while data analyzing, which is data cleaning and its preparation. So both of these are very simple and also very important for data analysis and also statistics. So make sure not to skip any part of this classes, because I'm going to be showing you with example and also effective methods which you'll be able to apply in this whole course. So without any further ado, let's hop onto our class and let's open up Jupyter Notebook on our device. First off, we have opened up the folder. I'm going to open up CMD, and from here I'm going to type in Jupyter Notebook. Now let's just wait for a bit until Jupyter Notebook opens up on our device on another web browser. So there we go, it has opened up, and then we're going to wait until the home screen is visible. Now let's click on New and click on Python 3 IP kernel. Now over here, I'm going to name it, let's say, I'm going to put in data prep and cleaning. Okay, so now we have prepared the file. Now the first thing that you need to do is you have to import the libraries and also create a sample data set, which you'll be able to work with. Okay, so first things first, let's type in import pandas. As you can see, let's just cut this off, and I'm going to type in import pandas as pd, and type in import numpy as np. Hit on Shift Enter and wait for a bit until you don't see any specific errors. If it doesn't show you off any specific error, then you'll be able to create a sample data set, such as type in data, or you can also put that like all of these in the same cell. Let's put in data equal third brackets. Then I'm going to put in, let's say, single quotation, put in name, single quotation, put in a colon, secondary brackets. Let's define in the names, let's say something like Alice. Then I'm going to put in something like Bob. Then I'm going to put in Charles, I'm going to put in David, I'm going to put in Eva. And then I'm going to put the last one, let's say I want 2 of them. So I'm going to put in a duplicate one. Okay, put in comma, move on to the next line, single quotation. Now I'm going to specify the age, colon, secondary brackets. Let's say Alice is 25. Bob is somewhere. I'm going to put in an NP error. So I'm going to put in NP.NAN, comma. Then it is going to be around 30. Then I'm going to put around 29, comma. I'm going to put in an NaN value, which is this one, comma, single quotation. I'm going to put in 25. Okay. Close off the secondary bracket with a comma. Then I'm going to put in the gender. Make sure all of them are in the same indentation level. I'm going to put in female, comma, male. Then I'm going to put in another male. I'm going to put in np.nan, comma. I'm going to put in female, comma. And the last one is also going to be female. That is it. Then I'm going to put in the country. Here I'm going to start off with USA. Next one is going to be USA in small letter. Then I'm going to put in Canada. Then I'm going to put in capital, Canada. Then I'm going to put in UK. Then I'm going to put in, let's say, USA again. Okay, because both of these values are basically the same and it defines Alice. Then I'm going to put in quantity. Here I'm going to put in, let's say, 2, comma 1, comma 3, comma, let's say 5, comma 2, comma 2. That is it. Now on the last line, I'm going to put in the unit price, colon, secondary brackets, let's say 20, comma 15, comma, np.nan, comma 10, comma, let's say 30, comma 20. Okay, so basically that is it. And on the last line, just close it off with the third bracket as we are done defining our sample data frame. Then you have to make sure you put in df equal pd, then put in dot data frame. Open up the parentheses and close off the parentheses and type in df. Hit on shift enter and basically you are good to go. You can also copy this or you can just paste it on another cell, let's say like this, and hit on shift enter. In that way, it will be validated and you will see a table like this will be created. Okay, so as we have created the data set, now we'll be able to get into data cleaning and also data preparation. First off, we're going to go through them step by step as this is a crucial step in data analysis with Python as it involves transforming raw data into a clean, structured form suitable for analysis. So basically, let's start off with the first one, which is data cleaning. This step basically focuses on fixing or removing incorrect, corrupted, or incomplete data. So first thing that we want to do is we are going to handle the missing values, such as the missing data can be filled with mean, median, mode, or removed entirely. In that case, let's start off by filling missing values with 0. In that case, we have put in df for our data frame. So here I'm going to put in fill NA, put in 0 and close off the parentheses. Hit on shift enter and it's going to remove all of the 0 values and it is going to put in, let's say, an average value of the 0 values or the missing values. Now, the next thing that I want to do over here is I want to remove rows with missing values. So here I can put in df dot drop NA, open and close off the parentheses, and in that way, it is going to remove all of the cells or all of the rows which have no values inside. Such as you can see, we had Alice, Bob, Charles, David, Eva, but here we have Alice, Bob, David, Eva. So there is no Charles in between, okay? Because Charles has a 0 unit price, so this one has been removed from the data frame. Okay, now the next thing that we're going to learn about is removing duplicates. So in an array, there could be several duplicates and also duplicate rows, which can distort the analysis. In that case, you can put in df, then put in drop, then underscore, put in duplicate. This is or this is the method which is going to basically remove all the duplicates, put in duplicates, hit on Shift Enter, and you can see we had two Alice, but now we only have one. So this is how you'll be able to remove the duplicates in a specific row. It helps to, make your array of data to look a bit more, effective and also professional at the same time, because we don't want the same value twice. So it can obviously disorient your analysis and make it repetitive. Now, the next thing that we're going to learn about is correcting the data types. Sometimes numeric data may be read as a text, which needs correction. In that way, you'll be able to turn it into a numeric data. And obviously, you might even face a couple of errors sometimes. In that case, if you want to correct the data, let's say I'm going to put in df. Then I want to validate the age variable. Age equal, put in df, then secondary brackets, single quotation, define in the age again. So the age variable is defined properly. AS, then put in TYPE. Now I want to turn all of them into integer values. So type an int inside of the parentheses after as type. So hit on Shift Enter, and all of the variables will turn into basic, the variable types. Okay. So now you can see sometimes it might show you off as an error, but it is totally fine. What you can do is cut this off and paste it back again and hit on Shift Enter. If it shows you off as, a couple of these errors, it is totally fine because it can also show you off as a couple of errors. So let's just skip this part for now and show that to you in the end. The last thing that you want to know about data cleaning is fixing the inconsistent data types, such as you can convert all country names to a standard format. So here I can put in df. Here I'm going to put in country, close off the secondary bracket, equal df. Here I'm going to put in country, close off the parentheses, close off the secondary brackets. Here I'm going to put in .str, and I'm going to put in .lower. Open and close off the parentheses, and in this way, it is going to turn all of those into a lower format. So you can see we have USA capital, we have USA, let's say small letter. So here what we can do is we can, copy this, Control C, and we can paste it right over here. In that way, you can see now it is still like this because it is getting the value from here. But if you want to print it out, it is also totally fine. So you will be able to print them out. Print df. Now you will see that all of them has turned into lower cases after you put in this command. Okay? So this is basically how simple it is. Now the last thing that I'm going to be showing you is obviously correcting the data types. So put that in first after you see this error. Okay, you can see we have the invalid literal for integer with base 10 and NPNAN. Okay, so we're going to fix this right now. So basically, this error happens because some value in the age column, or let's say rows, are strings like NAN. You can see we have NPNAN and also NAN right over here. Okay, so Python can't convert these directly into integers using AS type integer. So what you basically have to do is you have to basically, avoid a couple of things. Let's just remove this and let's type in over here. First off, you're going to convert the age column to numeric, forcing the errors to NAN. So type in df. Here I'm going to put in age, secondary bracket, put in equal pd dot to underscore. Then I'm going to put in 2, and here I'm going to put in a numeric, open up the parentheses, put in df, secondary bracket. Here I'm going to put in age, close off the secondary bracket, put in comma, errors, equal. Then you're going to put in single quotation over here, and you're going to type in course. Okay, type in course, close off the secondary, or let's say the single quotation. Now you can safely fill the missing values and convert to integer. So type in df, secondary bracket, put in the age value, close off the secondary bracket, dot fill, NA, open up the parentheses, put in df, then secondary bracket, define in the age, secondary bracket over here, put in dot with median values, open and close off the parentheses, and put in place equal true. Then close off the parentheses, and then I'm going to put in df. Here I'm going to put in age, secondary bracket close, put in df, put in age again, close off the parentheses or the secondary bracket, put in as type, and then you're going to make sure you put in the integer value. Close off the parentheses and hit on shift enter. Again, if you see this error, like, future warning, it is because of the in place true on a chained assignment. And this is a common warning in pandas, and it's letting you know that this behavior might break in future versions like pandas 3.0. So the newer method of putting in the median value is changing this. Here, I'm going to make sure I'm just going to convert this. I'm just going to cut this off. And here, what you want to do is you just want to type in df, type in age, close off the secondary bracket, put in df, age, secondary bracket over here. And I'm going to put in fill na, open the parentheses, put in df, secondary bracket, define in age. And here, close off the secondary bracket again, and put in just median. In that way, you're just going to make sure that everything is validated, and hit on shift enter, and you will see that there is no error after this. Okay, so this is basically how it is going to work, and you'll be able to work according to what I put in over here, and it is going to be effective. Okay, so now that is basically it for data cleaning. Now let's learn about data preparation. So data preparation is also quite simple to do if you have followed up to the steps that I have shown you in this part. Okay, so data preparation is basically a step which makes the data ready for analysis and modeling, such as making it visualizing and also making it statistical and also, let's say, ready. Okay, so first things first, what I can do over here is I can feature the engineering, like creating new columns from existing ones. Let's say I'm going to put in df. Here I'm going to put in total underscore price. Here I'm going to close it off, and I can put in equal df. Then here I'm going to put in the quantity. So I'm going to make this out of this existing, column. So I'm going to close it off, and then I'm going to put in an asterisk sign, df. Here I'm going to put in, let's say, the units underscore price. Close off the parentheses, the secondary bracket, and hit on shift enter. Now, if you want to also print it out, so here I want to print out, let's say, the total price. And you can see it is still not showing me the total price from the specific data because it has just been applied. So here I can put in single quotation and hit on shift enter. And you can see total price has been printed out, but it is not showing me the whole data frame because it has just been printed right now or just been applied right now. Okay, in that way you're going to make sure that it is just created right now. Okay, now what you can do is you can type in print open parentheses df and hit on shift enter, and you can see now we have the gender and also the total price right over here. We also have the NaN value over here, but it is still working. Okay, now the next thing that we're going to learn about is encoding the categorical values. So encoding the categorical values means converting the text label into specific numbers. In that case, you have to use pandas. For using pandas, I'm going to put in pd.get underscore, I'm going to put in dummies. After dummies, open up the parentheses. Here I'm going to put in df secondary bracket, put in the secondary bracket over here again after the df, and let's put in the gender value. After the gender value, close it off with the secondary bracket and then close off the parentheses. In that way, one hot encoding will be applied, and you will get all of the Boolean values if the female, male, the NP, NaN are true or false. So for the first one, which is Alice, female, which is true, male, which is false. So that means Alice is female and there is no NP, NaN error. You can see there is only one NP, NaN error, which is, let's say, for Charles or David. Let's say for 2, that is Charles, so that is it. Okay, so we have this NaN error for Charles. Okay, now the next thing that we're going to learn about data preparation is scaling and also normalization, which is useful for machine learning models, such as sklearn, reprocessing, and so on. First things first, what you have to do is you have to make sure you have this from sklearn.pre, then put in processing. Now, it might show you off as an error if you don't have, sklearn installed. So I'm going to type in min max, put in scalar. Now, if it shows you an error, it is totally fine because we are now going to install it on our device and also Jupyter Notebook. So in the same way, what we're going to do is first off, let's just like paste it over here. And over here, I'm going to put in pip install scikit, then put in learn. Hit on enter and wait for a bit until all of the modules has been installed and show you off as a notification. Okay, so let's wait for a bit and I'm going to just directly show you directly to you so that it doesn't, show off any errors. Now you can see there are not any errors because all of them are installed. So let's just start off our data preparation. Over here, after, installing scikit-learn, here I'm going to use the scalar, such as type in scalar equal, type in minimum, maximum, scalar. Open and close off the parentheses, type in df, secondary brackets, put in income. Here, I'm going to close off the secondary bracket 2 times, equal scalar dot fit underscore transform. Open up the parentheses, df, secondary brackets, put in single quotation, type in inform, like single quotation, and close off the secondary bracket twice and the parentheses at the end and hit on enter, or let's say shift enter. In that way, you'll be able to make sure that the data is ready for machine learning models. Okay, so if you're doing machine learning with Python, it is going to be very simple for Python to analyze it, and also you'll be able to model it throughout the whole way. Now, the last thing about data preparation that we're going to learn about is splitting the data. So often in data analysis, you are going to need training and testing in machine learning tasks. So if you want to prepare your data for training and testing, what you have to make sure you also use the scikit-learn. So start off with from sklearn dot model underscore selection. Here I'm going to import the train test split. Train test underscore put in split. It might also show you off as an error, but let's just try it out first. Type in train, comma, put in test equal train test split, open the parentheses, df, comma, test underscore size. After that, type in equal 0.2 and close off the parentheses and hit on shift enter. If it doesn't show you off any errors, that means your data has been splitted, and also it is trained and prepared for testing for machine learning tasks. So, data cleaning ensures the accuracy and consistency, while data preparation helps in structuring and also transforming the dataset for effective analysis and modeling. Now, if you want a visual example, let's start off with a new dataset. Let's say I'm going to put in import pandas as PD. I'm going to put in the data equal third brackets. Let's start off with the name. I'm just going to put in capital name, colon. Let's just put in the exact data that I want to work with. I'm just going to put all of these over here, and this is the exact data that I want to work with. Close off the third brackets, put in df equal pd dot data frame, open parentheses, put in data, close off the parentheses, print, and put in df. In that way, it is going to print out the data frame in just a bit. It might take a bit of time because it is being prepared, and after a while, it is going to just show off all the data that is being created. So basically, even after a time, if it doesn't show up, it is totally fine. Because most of the cases, what happens is that if you already have a data frame, it's not going to work and it is basically just going to overlap. So let's get back to home and click on new. And we have a new file. Let's just paste it over here and it will show you off the data. So let's just fill out the missing values. Let's put in df. Here I'm going to put in single quotation age. Here I'm going to close off the secondary brackets, put in df, single quotation age, secondary brackets, put in dots, fill and a, put in df, then open up secondary brackets, here age. Here I'm going to put in dots mean value, open and close. Here I'm going to put in df city equal df city. Here I'm going to put in equal city, so I'm going to put in dots fill and a. I'm going to put in unknown if it doesn't find off any data. This is how it's going to be. And I'm going to print out df again. There we go. So whichever one, it cannot find any data. So it's just basically showing me as unknown. Okay. We can also remove the duplicates using specific IDs. So here I'm going to put in df equal pd dot data frame, third bracket. Here I'm going to start off with ID colon, let's say 1, 2, 3, 4, 5. You can do that if you want to. Now, if you want duplicates, I can put into 2 times and then close it off. Let's put in another comma. And here I'm going to put in the name, secondary brackets. Let's say Alice, comma, let's say Bob. I'm going to put in Bob again. Here I'm going to put in Charles. Comma. And close off the parentheses. First off the third bracket and then the parentheses. Let's put in df. I'm going to put in drop and a. Or let's say instead of that, you can put in df first and then put in drop underscore. Let's say put in drop underscore duplicates. Open and close off the parentheses, and in that way it is going to drop all the duplicates, and then you can type in print df. In that way all the duplicates will be dropped. Okay, we can also feature the engineering such as create more units and create more columns, and you will also be able to encode the categorical variables, such as in my previous class I've shown you with false and true. In that way, if you want 0 values and 1 values, you're going to put in df equal pd dot data frame, open the parentheses, then the third bracket, single quotation, gender, colon, let's say secondary brackets. Here I'm going to put in male, comma, female, comma, female, comma, and then the last one is going to be specifically male. And then what you want to do is close off the secondary brackets and then close off the third brackets and then the parentheses. Okay, now I'm going to put in encoded equal pd dot get underscore dummies. After the dummies, open up the parentheses. Here I'm going to put in gender, then close off the secondary bracket and also the parentheses, print encoded. And there we go. We still have on false and true, but you'll be able to turn them into 0, 1. If you just want these values in 0, 1, just add in another line. First off, we're using the controller as encoded, right? So here after encoded,
I'm going to type in encoded and then put in dot as type. After as type, just put in the integer over here. int, close off the parentheses and hit on shift enter, and they will appear in 0 and 1. Okay, so this is basically how simple it is for data preparation and also data cleaning, and also with examples. Okay, so make sure to practice all of these. Now I'm just going to basically change this example of data clean and prep. Okay, so basically I'm going to have all of these files into my resource folder. So I'm going to be adding that. And what you can do is you can just open up any one of them and check up the commands with Jupyter Notebook. And you can also copy and paste them to check them if it is working or not. And after that, if you still face any errors, feel free to ask me anytime. I'm always there to help you out. So just keep on practicing and do not skip any part of these classes because these are very important. So thank you again. And without any further ado, let's move on to our next class of data analysis with Python. Welcome to a new class of data analysis with Python. In this class, I'm going to cover everything that you need to know about handling missing data, which is NaN, and filtering data using conditions. Now, both of these have been covered for the basics in my previous classes. So if you didn't check out those videos properly and don't know how to do it yet, then I would suggest you go check out those videos again because those are going to be used in this class too. And I'm also going to be applying in new functions and new applications of integration, which is basically going to help you to analyze your data a bit more better with more conditions. So without any further ado, let's open up Jupyter Notebook and make sure not to skip any part of these classes. As you can see from my screen, I have opened up Jupyter Notebook on my device. First thing I'm going to do is I'm going to click on Python 3 ipkernel, and then I'm going to put in a name. The name of this is going to be missing data, and I'm also going to be applying in a couple of things such as conditions. So the first thing that you're going to need is a simple dataset or a sample dataset with missing values. So first off, let's import the necessary libraries. Import pandas as PD. I'm going to import numpy as np. Then I'm going to create a sample dataset. So type in data equal third bracket. Here I'm going to start off with the name, colon, secondary brackets, Alice, Bob, Charles, put in David, also going to put in Eva, comma. Then I'm going to put in the age value for each and every one of them. Let's say I'm going to put in 25, comma, or 24, whatever it is. I put in np.nan. Then I'm going to put in 30. I'm going to put in 22. And then I'm going to put in np.nan again. Okay, so this should allow me to put in two nan values. Then I'm going to put in my gender. Here I'm going to start off with female, male. I'm going to put in np.nan, comma. Here I'm going to put in male. I'm going to put in female. Okay, so this is how you can see that I have put in all of the things that I basically need. And when you're defining an np.nan, you don't basically have to put in quotation because that value is already missing. Then I'm going to define the score of each and every one of them, such as, let's say, he scored or she scored 85. Then I'm going to put in 90, np.nan, comma. I'm going to close off this double, comma over here. And then I'm going to put in 66, and then I'm going to put in 76 over here.
close off the secondary bracket, and close off the third bracket at the end. Now I'm going to define my data frame. So df equal pd dot data frame, open parentheses, and define in the controller, which is data. Then I'm going to print out the data frame. So close it off like this and hit on shift enter. And after that, you can see we have 85 and we have 2 commas. So let's just close off 1 comma. And in just a bit, it is going to give you the output, such as any n values right over here, this one, and this one. There's also an error over here for Charles. Okay, so as we have all of these values, now we're going to go through them step by step to handle the missing data. Such as the first thing that you need to do is you have to detect the missing values. Now we already have detected it, but you have to show which values are specifically missing. So I want to use a specific function called print df dot is null, open and close off the parentheses, and at the end do the same thing. Hit on shift enter and wait for a bit. If it doesn't work out for you, just press on Ctrl X and paste it on this line, and it will show you the exact lines where it is missing, such as false, false, false. We have false, we have true. So there's the missing value. There's the missing value over here, missing value over here, and also another missing value over here. So basically we have 4 missing values. Now, if you want to count the total missing values per column, then you're going to put in, let's say, print, put in df dot is null, open parentheses, keep it empty, and you want to sum it up. Now close up the parentheses at the end and hit on shift enter, and it will show you in the age section we have 2 null values, in the gender we have 1, in the score we have 1, which rounds up to 4. Okay, so basically there are 4 missing values. Now we're going to drop the missing values, which is going to basically just drop the rows with any missing values in it. So here you can put in df underscore drop, then underscore any. This is the variable. I'm going to put in df dot drop na. You can see this is how it looks like. I'm going to put in drop na and open and close off the parentheses. That's all that you need to do. And then it will basically just drop all the missing values in your array of data or your data set. You can also drop rows where all values are missing. So you can put in, or let's say all of the values of age is going to go missing, all the values of score is going to go missing. In that case, you're going to put in drop underscore all equal df dot drop na, open parentheses, how is going to be equal, single quotation all. This is exactly how you want to put it, and if you hit on shift enter, then all the values of the rows which are basically missing is going to be removed. In that case, age is going to be removed, and also score with also gender is going to be removed. So only the name where it doesn't have any n values is basically going to be there. Okay, so now you know how you'll be able to drop any missing value and how you can drop all missing values or all rows where missing values are available. Now, if you want to drop column with any missing values, you basically have to do the same thing, but in this case, you have to work off with axis. Put in df underscore drop underscore columns. I'm going to put in single underscore, not double, after columns equal df dot drop na. After that, open up the parentheses, and the axis that you want to work off with is 1. In that way, columns are selected and then the columns will be dropped. Okay, so now you know about how you can drop missing values or missing data in rows and also columns. Now, what we want to do is the next thing is filling out the missing data, such as we're going to start off by filling with a specific value. So wherever it has the specific value of np error, or let's say nan, I want to change it to 0, which is an integer value. So I'm going to put in df, then put in fill underscore constant, which is going to be equal to df dot fill na, which is going to find out all of the nan out like errors, and then I'm going to hit on shift enter. In that way, wherever it has the nan error, it's going to fill it up with 0. Now you want to fill it with mean, median, and also mode. So there are like different for every one of them, such as if I put in df, here I'm going to start off with the age value. So age is going to be equal to df age, close off the secondary bracket, fill NA, open up the parentheses, df, then here secondary bracket, here I'm going to put in age, close off the secondary bracket, and then put in the mean value. Open and close off the parentheses, also a parentheses at the end, and if you hit on shift enter, it will basically change the values where it has the NA and error, and it will turn into, let's say, the 0 value. If you want the median value, let's say I want the median value of the score. In that case, I'm going to put in df, single quotation, score, close off the secondary bracket, equal df, secondary bracket, define in score again, close off the secondary bracket, put in dot fill, NA, open the parentheses, df, and here I'm going to put in score. Here I'm going to close off the parentheses, dot median. Okay, open and close off the parentheses and hit on shift enter. If it doesn't show you off any errors, that means that it has already turned the values into a median value. Now, the next thing that I want to do is how you'll be able to get the mode value. In the same way, just put in df. Now I want the gender value. So here I'm going to put in gender, close off the secondary bracket, df secondary bracket, gender, close off the secondary bracket, put in fill NA, open the parentheses, df secondary bracket, gender again, and then you want to put in the mode value. That's all that you need to do. How simple it is. Close off the parentheses. If it doesn't show you off any errors, then it means it is done. Okay, now what we want to do is we want to forward fill with previous values. If you want to fill it up with previous values, it is also totally fine. Now, another thing that I can do is I can print out df and check it out. You can see it is still going to show me off as errors. But obviously all of them have a different, let's say constant and also different variables. If we try to put in print and then put in like this, let's just close off with the single quotation and it will print out the exact value because there is specifically no variables that we are using. And these are basically just functions to define in these values. Okay, so this is how it is going to work. You can put in the null value, you can put in the fill and a value, and it will still work on the database and it will change inside the database. It is not going to put any changes on the previous answers or anything. Okay, so if you want to do is forward fill, the forward fill is to fill it with previous values. In that case, I'm going to put in df underscore ffill equal df. Here, I'm going to put in fill NA, open parentheses, define in the specific method that you want to use, equal, and the method that I want to use is ffill. Okay, close off the parentheses and hit on shift enter, and you can see sometimes this is how it works. Okay, now this one basically shows off because it cannot find the IP kernel and bfill over here. Now bfill is basically for let's say for backward fill, but ffill, so that is basically for for the forward fill. Now the forward fill might show you off as a couple of errors in couple of methods. So what you want to do over here is basically you have to change the method. So if you want to change the method, what you can do is that it is also for future proofing because this method might not work in the next versions of pandas or numpy. In that case, you have to put in a df underscore ffill, put in equal df.ffill, and open and close off the parentheses. Okay, in this way, this is how it is going to work. But the previous thing that I used as method, that is basically for the older version. Now, like in the same way, if you want to use the older version of backward fill, you have to put in df, just like this, df underscore bfill equal df dot fill NA, open parentheses, and define in method. Here you want to put in bfill. So this is the previous method and it might not work. So if it doesn't work either, you have to put in df, put in underscore bfill, put in equal df dot bfill, open and close off the parentheses, and it is going to work. So this one is basically for forward fill, and this one is basically for backward fill. So this basically uses the previous values in the specific listed arrays, and also for the backward fill, it uses the next value by the backward fill. So these work the same way, but are just preferred methods to avoid warning for future errors. Okay, so obviously it changes from time to time when the version of the libraries change. Okay, so the next thing that we're going to learn about is interpolating with the missing data, such as numerical columns. So if you want to work with numerical columns, you have to interpolate it. In that case, you have to verify or validate the data frame first. And here I'm going to put in interpolated, which is going to be the variable. And here I'm going to put in df dot interpolate. That's it. Shift and enter, and it might also show you off as an error, which is basically for future version. Now, this future version might not also work in a couple of cases. Now, if this method doesn't work out for you, what you have to do is an optional method by interpolating only numeric columns. Now, in a couple of cases, there are NaN values which are still being read as a string value. In that case, you're going to only work with numeric columns. Here I'm going to put in df. Here I'm going to put in df dot select underscore dtypes, open parentheses. Here I'm going to include the numericals. Okay, include equals, secondary bracket. I'm going to put in number, secondary bracket to close it off. Close off the parentheses, and then I'm going to put in dot columns. Close off the secondary brackets, equal df dot select. Here underscore dtypes, open parentheses, include equal secondary brackets, and after the secondary bracket, you're going to include the numbers in the same way. So here, put in number, close off the quotation and the secondary brackets, close off the parentheses, and then define in interpolate. Open and close off the parentheses, and it might show you off something like this, and it is totally fine sometimes. So basically what we just did over here, there is 2 underscores, so let's just keep it like that and keep it single quotation, and you can see now this is working. So we can just remove this cell, and we can keep it up till here. Okay, now the next thing is that we're going to learn is about checking again to ensure all missing values are handled. In that case, you're going to type in print, open parentheses, df dot is null, open up the parentheses, then put in dot sum. Hit on shift enter, close off the parentheses, and now you can see we have only one error in gender. And every one of them has been handled because all of them has been turned into 0 as integer. Okay, and as the gender value is being read as as a string, so that is basically not going to work. Okay, and that is not going to be interpolated. So that means now you have learned about how you'll be able to handle missing values in data analysis. Now let's go through the summary. When you use df.isNull, it detects the NaN errors inside of your array or your data frame. When you put in df.dropNA, like this, okay, there we go. This one basically removes the rows or columns with NaNs. If you put in df.fillNA and then put in the specific value, okay, that specific value basically works with, replaces the NaNs with the specific value, such as 0 in this case. When you put in df.interpolate, it basically interpolates the missing numerical values and turns them and keeps them as a numerical value, and also changes the string value into numerical. Okay, and then we use the method fill like this. Okay, but instead of method fill, what we used is df.fill. That also works as the forward fill, and it fills the missing values with the next or the previous value. And for the bfill that we used is used for backward fill with the missing values of the next data. When we use df column.mean, okay, that basically uses mean to fill NaNs. And when you put in column mode and 0, which is basically this, you can also put in 0 over here and work with it. It will still work. It basically uses the mode to fill categorical NaNs. Okay, so now you worked, and now you already know about how you'll be able to work and fill out the missing data or missing NaN values in your data set. So as then we are done with the data set, the next thing that we're going to learn about is how you're going to work with using conditions for your data filtering. So for data filtering, what we're going to need is that we basically have to, create another data set. Now, another thing that you have to know about is that in data analysis with Python or pandas, filtering means selecting rows from a data frame that meet certain conditions. This helps in narrowing down data to what's relevant for analysis, such as selecting rows where age is greater than 30, such as gender, which is equal to male, salary, which is in between, a specific value. So all of these are kind of like conditions. So if it meets up your criteria, then it is going to work. First things first that we need to do over here is that I'm going to create the data set, such as I'm going to import. Okay, what we're going to do is that we're basically going to keep it like this, and we're going to save this file. And let's just create another data set because it is not going to work when we put in two data sets inside. Okay, let's just change it to, let's say, data analysis or filtering data. Here, I'm going to put in import pandas as ed data equal third brackets name, secondary bracket first, Alice, comma, Bob, comma, Charles, comma, David, Eva. Then I'm going to put in the age value, secondary brackets, let's say 25, comma, 27, comma, 30, comma, 22, comma. We have 6 or 5 values, so I'm going to put in another one, 55. Then the next one is going to be the gender. I'm going to put in male and female, F, M, M. Then I'm going to put in another male. And the last one is obviously going to be a female. Comma. And the last one is going to be working as a salary. So put in that, let's say 50,000, comma, 60,000, comma, put in 55,000. Then I'm going to put in 80,000. And then there's going to be 45,000. Okay, so we are basically done with all of these values. Here I'm going to put in df equal pd dot data frame, open up the parentheses, data, and then I'm going to put in print df. There we go. We have the values for every one of them. Now we're going to write a condition, such as, let's say I'm going to put in a condition variable, which is going to be equal to df single age, close off the parentheses, and let's say I want the people who are above 30. So here, if I put in like that, it will show me off like whoever is above 30. Okay, so here I'm going to put in that. I'm just going to put in print, open parentheses, condition. Now you can see there is specific errors that is working out like that. So I'm going to put in condition. Now you can see we have false, we have true, we have false, false, and true. So there we have true values, which is 2 times. That means only 2 people are above 30. But one is like 30 age, but I didn't want equal to 30. I wanted, greater. So I'm going to put in equal to 30. And now if I put in like that, now you can see there are 2 true values and 3 true values and 2 true like false values. Okay. So this is basically how you can put in conditions. Now, what you can do is that you can also filter the data frame, such as if I put in filtered df equal df, then I'm going to put in condition, where I'm going to be using two condition. If I put in print, I'm going to put in filtered df. Hit on shift enter, and it will also give me the name, age, gender, and salary directly from the data set, and it's going to put it up over here, which meets up the criteria. Okay, so this is basically how it is going to work. You can also use multiple conditions, such as in this case, I want people greater than 25, but I only want the male genders. Okay, in that case, I'm going to put in filtered underscore df, which is going to be equal to df secondary bracket open parentheses, df secondary brackets. Here I want the age to be validated. Then I want greater than 25. Close off the parentheses. I'm going to put in an ampersand because I'm going to be using another condition, such as df secondary brackets. I want the gender secondary bracket to close it off, and quotation. Here I'm going to put in double equal single quotation. I'm going to put in male. So only the male persons will be validated. Here I'm going to put in parent. I'm going to put in filtered df. And there you can see only two people which are male are above 25. If I put in, let's say, above 30, you can see only one. If I put in above 40, you can see there is specifically none and an error. Let's just put in a bit of space, and you can see it is not working. Okay, so I'm going to put in just 40 over here, and you can see there is no data set that meets up the criteria and the condition. In that case, I'm just going to put in 35. You can see only one people is above 35. If I put in 37, there's also going to be an error because it is going to show me empty data frame. But if I put in greater or equal to 37, then there we go. We have Bob, and age is 37, gender male, and the salary is 60,000. Now, the last thing that we need to learn about is using query method, which is totally optional because pandas also supports SQL like filtering. In that case, you can work off with df.query. Open up the parentheses, double quotation, put in age greater than 25 and gender, which is double equal to male. Single quotation and double quotation to close it off. Close off the parentheses and hit on enter, and it will show you off that query method, or this method of SQL like filtering also works in data analysis with Python, but it only works in cases when you import pandas on your dataset. If you do not put in pandas, let's just remove this. You can see everything will work except this. Okay, so you have to make sure you put in data frame first, and you have to make sure to put in PD. Now we already are using PD, so it is working properly. But if we did not, it's not going to work. So import pandas all the time as PD. Okay, but if you try to put in with some data sets which does not have pandas, it is not going to work properly. So now let's get into the summary. When we put in filter age, which is basically this, okay, or you can also put in like this, and this one is also here. So basically it filters the df age, which is greater than 30, and creates its own data set by analyzing it. You can filter by gender. What we used over here is gender over here, which basically filters the data and meets up the criteria of what you exactly want with the specific criteria. You can combine you can combine ampersand to apply and combine two conditions and work along with it. So if you're working with two or more conditions that you want to work in a specific data frame, you have to put in the ampersand over here, which basically works like an AND gate in logic. Okay, you can also combine with OR, When you are putting or, this is basically how you are basically working with, such as df and then df again, and then define in the condition, such as this specific line. This basically works as the OR gate in logic and works off with analyzing your data. When you are using query, which is over here, it basically uses the SQL filtering, which is basically and mostly for data analysis on web pages and also for machine learning. But as we have pandas, it is also working properly. So that is it for this class on how you'll be able to filter the data. And also I've shown you about how you can work with conditions. So thank you for watching this video up till the very end and hope you understood about everything in this class. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. Another thing is that I'm going to be attaching all of these resource folders or resource file with this whole, course, which is going to be there in the resource folder. So if you are still facing any errors, check out these command snippets, which I am using. You can try copy pasting methods to check it out if it is working. You can tweak up the data if you have your own data set, and then you can work along with it. So thank you again. And without any further ado, let's move on to our next class of data analysis with Python, and make sure to keep on practicing after each class. It is very simple as I'm showing you all of the methods that you need to apply.
Welcome to a new class of data analysis with Python. In this class, I'm going to be showing you everything that you need to know about sorting and indexing, and also we're going to be creating new columns in the dataset, and how you're going to do that, I'm going to show everything in this class. So make sure not to skip any part of this class, because I am also going to give you a brief explanation of everything that I'm going to be showing in this class. So without any further ado, let's move on to our class by opening up Jupyter Notebook on our device. So as you can see from my screen, I have opened up Jupyter Notebook. Let's just create a new file. Let's say first thing that I want to create is going to be sorting. Okay. So before getting into the practical part, we also have to know about what is sorting and what is indexing. First off, sorting means rearranging data based on the values in one or more columns or index. There are common functions of sorting such as sort values and sort index, while index means selecting specific rows and columns using labels or position. The common methods of indexing are location, which is label-based, and iloc, which is position-based. So let's start off with sorting. When you want to start off with sorting, you have to import the necessary libraries, and the most important one is pandas. So I'm going to import pandas as PD. After that, you are going to create a sample dataset. Let's say data, name, Alice, Bob, Charles, David. Okay, I'm going to be using 4. So let's put the same thing as age. Let's say 25, 56, 33, let's say 24. Okay, that's all that I'm going to put, comma. And the last one I'm going to put in as score. Let's say I'm going to put in 85, 90, 78, and then 88 over here. Close it off with the third brackets and mention the data frame with PD, data frame, open it up and put in data as the variable and print out the data frame. There we go. Now in this way, this one has been shown. Now the next thing that we want to do is we want to sort out one by one. An example like age. In that case, I'm going to put in df sorted age equal df dot sort underscore values. Now I'm going to sort it out by age. So put in by and define in the age value. Here I'm going to put in print df underscore
then put in sorted underscore age. Hit on enter. And now you can see that it has sorted out the age from the most lowest to the highest. So we also have the indexes, David, which is in 3, then we have 0, then we have 2, and then we have 1. So you can see 24, 25, 33, and then we have 56. In the same way, you can do the one by score. Let's say if I put in score over here, now it is going to be an ascending order, such as 78, 85, 88, and then 90. So you'll be able to sort out by columns. Now it's only going to work on specific cases, okay? If it only has numerical and float values, this is going to work. If it has a single NaN value, or let's say 0 value, it is not going to work. So first off, you have to make sure you change the value into 0, and then you have to basically change it, okay? Only then it will work. Now, let's sort by multiple columns in like an example, score, and then the age. In that case, I'm going to put in df sorted equal df dot sort underscore values. Open parentheses, then put in by equal secondary brackets. Let's say I'm going to define in the score, comma, single quotation, age, close off the secondary brackets, put in comma, and then define in ascending. Okay, now after you define an ascending, put in equal, then first off, put in false, comma, and then put in true. Close off the secondary bracket and then the parentheses. In this way, it will be dedicated and also validated. Then I'm going to print out the df sorted, close off the parentheses, and now you can see age and score, both of them has been fixed. Okay, so age, we have this 90, our age is 56 by 90, we have 24 by 88, we have 25 by 85, and then we have 33 as 78. Okay, so this is basically how it is going to work. Okay, so now you know how you'll be able to work along with it. If you change out the values, it is also going to be validated over there. Let's say we have 90 over here for 56, so 33 is 78. If I put in 100, and now you can see we have Charles 33. You can see I'm going to check on Charles. Charles is 33, and that is 100. So that is 100. Then we have is 56, which is 90, 24, which is 88, and 25, which is 85. Now, in some cases, it might not be, validated because there are different numericals, but it is working as, the score value. It is like validating the score more. Okay. So this is basically how you're going to be sorting out by multiple columns. Now, if you want to sort out by index, you will also be able to do that. In that case, you have to put in df sorted. I'm going to name my variable as index equal df dot sort underscore index. This is how you want to put it. I'm going to change it to dot. And here you want to open and close off the parentheses. And I'm going to put in print df underscore sorted underscore index. Now, in this way, you will find out that this is going to show up with the index, such as 0, 1, 2, and 3. Now, all of these have been changed, but now you can see this one is working properly. You can also use the query method if you want to, but I'm just going to be skipping that part. Now, we're also going to be learning about indexing. Now, I've already shown you and told you about what is indexing, which basically selects specific rows and columns using labels or position. And the most common method for them are location, which is label-based, and iloc, which is position-based. So now let's show you how you're going to access a row by index label with the location. Now, in that case, first off, what you have to do is you have to put in df.set underscore index. After that, open up the parentheses, define in the name, comma, and then put in place equal true. Close off the parentheses, define in print, put in df, then put in the location. Open up the secondary bracket, define in Alice. Close off the quotation, close off the secondary brackets right over here. and then close off the parentheses. Then we just want to do is you just want to hit on enter. Now there are basically two lines that we're using. So the first line is basically to set the custom index, which is optional. And then we get row where the name Alice is. So if I put in shift and enter, now you can see the age is 25, the score is 85, and the name is Alice, and the D type is integer 64. Now the next thing that you can do is you can access a row by index position with ilock, which basically gets the first row. So if you want to get the first row, you have to type in print, open parentheses, df dot ilocation 0, and then close off the parentheses. In this way, it will show you off the first one. If you want to use a different name, let's say maybe I want Charles, then it will show you off the name of Charles. Now you can see Charles is not over there, so I'm just going to change out the value. Let's say what I can do over here is I can type in Bob and hit on enter. If it still doesn't work, you can see we have the df index as name. So in this case, there is the name of that is Bob, as you can see, and it is only validated with the first one. Okay, so only the first one where the row of Alice is, it is going to work like that. But if you don't have it, it's not going to work. So in that case, the first one is Alice. So you'll only be able to work with Alice. Now, these errors mainly appear up because it cannot find it. Now, what you can do over here is even if I try to search up for Bob, it might show you off as an error. In that case, you're just going to make sure you play in everything, and then you will see that it will show you off the age and the score of Bob. In the same way, if you want to find out of Charles, it might show you off as an error like this, but you just want to, play all of them again, and there you go. You will get the data of each and everybody. Okay? Now, in the same way, if you want to use ilock, type in print, open parentheses, put in df dot ilocation, secondary brackets, and here I'm just going to put in iloc 0, secondary bracket, close off the parentheses, hit on enter, and there you can see we have the D type of 0. If I want to put in 1, there we go, we have the Bob. Then if I put in 2, I'm going to get Charles, and if I put in 3, I'm going to get David. Okay, so this is basically how you'll be able to access row by index position with ilock. Now, the next thing is about accessing specific rows and also columns. If you want to access specific rows and columns, what you basically have to do is you have to type in print, open parentheses, df dot loc, secondary bracket 2 times. Then I'm going to put in Alice, comma. Now, I also want it of David. So I'm going to put in David, close off the secondary brackets, put in comma, and I only want their age and score. In that case, I'm going to put in age, comma, score. Okay? Secondary bracket, close it off 2 times, and close off the parentheses. Hit on shift and enter, and you can see sometimes it might show you off as an error because there is a problem here. Shift and enter, and there we go. The age of Alice is 25, and the score is 85. David is 24, and score is 88. If you want to change the name, let's say maybe I want Alice and Bob, and I also want to change this for, let's say, Charles. There we go. Now we have Charles and Bob's age and score. So this is basically how you'll be able to access specific columns and rows. If you want to put in more values, you can also do that. Let's say I'm going to put in country. Secondary brackets. Let's say in this case, USA, Canada, UK, let's say UAE. And play all of them along. And if I put in score, comma, I'm going to put in country. Then if I play it, you can see we also have the variable and the data of the country. Okay, so this is basically how you'll be able to change the values. And also you can access specific rows and also columns. Now, the next thing that you're going to learn about is resetting the index to default integer. If you want to reset the integer values, you have to put in df underscore reset as the variable. we put in df dot reset as the function and define an index. Open and close off the parentheses and put in print open parentheses df underscore reset. And then everything will be turned into the default integer value. So this is basically how you're going to work with sorting and also indexing. So you can see how simple it is to work with data analysis when you are sorting and you are indexing. So as we're done, I'm just going to change this sorting and indexing. Okay, so now let's just close off this file. Let's say first off, cancel and save up the file, and let's close it off. Now the next one, I'm going to create another file or another notebook. Now let's just save it as, creating a step-by-step method or creating new columns. So I'm going to put in creating new columns. Now, as we're going to be creating new columns in Jupyter Notebook for data analysis, I'm going to show you a step-by-step example of creating new columns. First off, creating new columns in data frame allows you to add calculated values based on existing columns. You can add constant values such as whatever you have in your data set. You can apply function to your specific columns and make changes. And also you can use conditional logic to generate new values based on what function you are using, such as mean, mode, median, and so on. Okay, so first off, let's import our necessary libraries, which is pandas. Then I'm going to create the sample dataset. In this way, I'm going to put in data, put in name, here I'm going to put in Alice, let's close it off over here. I'm going to put in Charles. I'm going to put in David. Let's just change it to Bob. Age. Here I'm going to put in, let's say, instead of age, what I can put over here is these scores, such as in math, Alice got, let's say, 88. Bob got 78. Then Charles got 88 again, or let's say somewhere around 92. And David got 88 or 99, whichever you feel like putting. Okay, I'm going to put in 88 so that I have a duplicate value and I will be also able to sort it out. Then for science, here I'm going to put in 90, 82, 85, and I want 95 for David. Close off the third brackets, define in the data frame, pd.data frame, then put in data over here. Then the next one, I'm going to put in print df. Okay, hit on shift enter and we will get the output. Now we're going to create new columns based on calculated values as average. In that case, put in df, and now for average, I'm going to put in the name average. Okay, close off the secondary brackets, open up the parentheses, df, then I'm going to get it from math value. Secondary brackets, going to add it up with the df of science. So here, I'm going to put in science. Close it off and close off the parentheses, and then I'm going to divide it by 2 so that I can get the value of average marks. In that case, I'm going to put in print df, and there we go. And the average value is 89. This is 80. Charles is 88, and David's is 91. Okay. Now we're going to add a column based on condition. An example, if the person passed or failed. So it should show me off as, a string value. In that case, I'm going to put in df results. I'm going to put in df secondary brackets. It's going to take it out by the average value.
close off these secondary brackets, and I'm going to make sure to apply it. Open up the parentheses, and here I'm going to use the lambda function x colon. It's either pass, and if x is greater than 85, it should show me as fails, like fail. I want to close off the parentheses, and then I'm going to print out the df. You can see Alice has passed, Bob has failed. You can see Charles has passed, and also that David has passed. But you can see it is not greater than 85, then it means Bob has failed. You can also reduce the value if you want to, let's say above 80. You can still see it as failed. But if you put in equal to 80, then everyone has passed. But I'm just going to keep it as 80 because one person should fail. Now, the next one that I want to show you is adding a column with constant value. In that case, put in df, then I want to put in the, column named year. In that case, equal to 2025. Here, I'm going to put in print df, data frame, and there we go. All of them were in the year 2025. If you want to add a column using a custom function, you can add in conditions and so on. And when you talk about condition, there are 3 types of condition, such as the if, elif, and also the else. Such as this is basically going to help me to give out the grade, such as A, B, C, D, E, or let's say even an F for fail. In that case, I'm going to start off with definition. I'm going to put in grade. Now, the variable that I want to put in is the score value. Put in a colon. Here, I'm going to put in the if function. If the score is greater or equal to 90. In that case, return the value A. Okay. Now here, I'm going to put in the elif of score. If it is greater or equal to 80, then I want to return the value of B. In the same way, if it doesn't meet any of these criteria, then it should return me as C. Then I'm going to do is I'm going to put in the conditional df secondary brackets. Grade is the category and the column name as the label equal df. Here I'm going to put in average, close off the secondary brackets, put in dots, and I'm going to put in apply grade. Close off the parentheses, print df. Hit on shift and enter, and now you can see Alice is B, Bob is B, Charles is B, and David is A. In that case, this is how it is going to work. Now, if you want to put in lower values, what I'm going to do over here is, let's say I'm going to make someone fail over here. Let's say if I put in 56, and now you can see Alice, or let's say Bob, has C. Okay, so you'll be able to work along with it. Now, we're basically done with the basic ones. Now, I'm going to show you the more advanced ones, which are lambda, np-where, and also map. Let's get into the brief first. Lambda is an inline function used with apply for custom logic, which I already shown you here. This is also termed as the basic, but you'll be able to make custom and get into more advanced features of data analysis with Python. When you're using np-where, it is a numpy function for vectorized conditional operation. In that case, what I'm going to do is I'm going to import numpy as np over here. Okay, now the next one is the map function. It is a function to map values in a common to new values, often used with dictionaries or even function. If you've seen my previous classes, then you already know about what is condition, what is dictionaries, and what are the functions. First off, let's start off with lambda. I already showed you one. Now let's show you how you're going to put in the math level. Let's say math underscore level. Now here, this is the new one. So I'm going to close off the secondary brackets equal df. Now I'm going to get it from the math section. Close it off, and then you have to put in dot apply. After apply, you're going to define in lambda, then I'm going to put in x colon single quotation as high. Now after high, I'm going to put in the if function. If x is greater than 80, else low. Close off the parentheses, and then I'm going to put in print. Print df. You can see there is a specific error, so let me just close it off over here, and you can see the math level is high, low, high, and high. Okay, so this is basically how you'll be able to use lambda for custom functions. Now let's show you how you're going to use npwhere. It basically adds a column that shows top if score is greater than the specific criteria, such as I'm going to be using the science grade or the science label. In that case, let's put in df. I'm going to put in science level secondary brackets equal np dot where. Open the parentheses df, and after df, I'm going to get it from science. Close off the secondary brackets greater or equal to 90, comma, up, comma, average. Close off the parentheses, and then I'm going to print out the data frame. In that way, you can see we have top, average, and also top, like average and top over here. Okay, you can also put in low if you want to. Let's say maybe if I put in low, it will also show me low if there is any. But you can see I did not define in where I can put in 90 because there is only working with two conditional. So in that case, you will only be able to work with two conditionals. In that way, you will see either it is top or low. You can also put in high or low in the same way as math level. In the next phase, what we're going to learn about is using the map function. While using the map function, it basically grades to description using a dictionary. So first thing that you want to do is you want to create a grade column. First off, I'm going to put in df, secondary brackets, and I'm going to create a grade. Here, as we have the grade, close off the secondary brackets, put in df, I'm going to get in from math. Now we already have put in a grade over here. As you can see, we have defined and grade, but you can also create a simple one. Let's say dot apply, then open up the parentheses. I'm going to define in lambda x colon a if x is greater or equal to 90, else parentheses b if x greater or equal to 80, and after that you want to put in the else. So here you want to put in else c parentheses 2 times, and then we're going to map it to the description. Then here I'm going to put in grade underscore map equal third brackets a colon excellent. After that, I'm going to put in b. If it is b, I'm going to put in good, and then c. In this case, I'm going to put in needs improvement. This is what I'm going to put in, and after the last line, close off the third bracket. Here I'm going to define my data frame, such as grade description, grade underscore description. Here it is equal to df secondary bracket grade secondary bracket over here, put in dot map. Open up the parentheses, grade underscore map. Then I'm going to put in print and then df. In this way, you can see we have this over here, such as the science level is this, and the grade description, Alice has good, Bob has needs more improvement, Charles has excellent, and David has good. So basically in the final output, your data frame now has several new columns created using different techniques such as math level via the lambda, science level via the npwhere, and also the grade description via map. So now that you learned every basics and also the advanced feature of data analysis using all of these functions for data analysis and also creating new columns. So make sure to apply these features and these functions in your own project. You can apply all of these in your mini project too, so that you get a specific result, and also you'll be able to create, new data sets from downloaded data sets too. So just keep on practicing and make sure not to skip any part, because all of these are quite important and all of these can be used in advanced features too. Okay, so thank you for watching this video. And if you still have any confusion or any question, feel free to ask me anytime. And also, I'm going to be having all of these files inside my resource folder, so you can check them out. You can try copy and pasting with your own data set and then just check out the result. So thank you again. And without any further ado, let's move on to our next class of data analysis with Python. Welcome to a new class of data analysis with Python. In this class, I'm going to be showing you everything that you need to know about data type conversion and cleaning a messy dataset. Now, both of these are going to be totally different, but I'm going to be showing you how you'll be able to convert them, and also using the exact same methods, you'll be able to clean a messy dataset too. So without any further ado, let's open up Jupyter Notebook and let's get started with this class. And just make sure not to skip any part of these classes. Now, as we have opened up Jupyter Notebook, we're going to click on New. And then we are going to have a new notebook. Let's say I'm going to have to name this Data Conversion. Okay, so here I'm just going to keep it Data Conversion. Now, what is data type conversion? Well, data type conversion is the process of converting data from one type to another. For example, you can change integer value into float values. You can change string value into integer value. You can change object value into date and time, which is common in pandas. It basically helps to ensure the data is in the right format for analysis, calculation, and also visualization. So let's go through them step by step. The first step that you want to make sure to do is you have to import the necessary libraries. In that case, let's import pandas. Now, the next thing that you want to do is you want to create a sample dataset. Data equal. Now, in most cases, what we did is we got the name and then we put in the exact other categories. But here I'm going to be mostly putting in numerical variables. So here I'm going to put in age. Let's say another thing that I'm going to do, in most cases we put in numbers like this. But here I'm going to put in 45, comma, 22, comma, and then I'm going to put in 30. And you can see all of them are red. That means it is showing it off like a string, but it is a string which looks like a number. So let's move on to the next one. Let's say the next one is going to be salary. The salary is going to be somewhere around 40,000, comma, then I'm going to put in 50,000 and then 60,000. Close off the secondary brackets, and this one is basically integers. Okay, so now you can see when I put in integer like this, it is detected as an integer. But when I put in quotation, it is defined or termed and detected as a string.
So this numbers that are over here is also detected as a string, but it looks like a number. Now I'm going to put in another value. Let's say join date. Okay. So here I'm going to put in colon. Let's say the first one that I want to put in is the date value. Now the date value also contains a specific format. It starts off with the year, the month, and the date. So here I'm going to put in the year, let's say 2025. Then here I'm going to put in dash. Here I'm going to put in 01-01. Close it off with the quotation. Then I'm going to put in 2025 07. I'm going to close off one of these dashes. 07, I'm going to put in 15. Comma. And the last one is going to be 2025 dash, let's say 03 or 04. I'm going to put in 20. So this is the exact format that you also want to put. And as we're done, we're going to close off the third bracket. Now, as we're done with the data set, let's define in the data frame. df equal pd dot data frame. Open the parentheses and name it as data. Now I'm going to print out the data frame, so put in df and hit on Shift Enter. In this way, the output will be given right over here. Okay. Now another thing that we do over here is we need the VBNet, okay, which checks the original data type. In that case, after the df, you're going to put in the types. Okay. Hit on Shift Enter, and now you can see age is termed as an object, salary is an integer value, and joined date is also an object. So in most cases, it is object. Okay. Now, as we have these numerical values, which are still being identified as an object, or let's say a string, we're going to convert them into an integer format. To do that, first off, let's type in df, and the one, or let's say the category that we want to change, is the age. After the age, close off the secondary brackets, df age, secondary brackets, and put in .as type. After that, open up the parentheses and type in integer. Hit on Shift Enter, and then it will turn into an integer value. You can also change up the join date in the same way. So let's put in df secondary brackets. Here I'm going to put in join underscore date. I'm going to put in small letter, close off the secondary bracket, put in equal pd dot to underscore, then type in a date, time, open up the parentheses and define in df, and then put in the join date again, underscore date, close off the quotation, close off the secondary bracket, and also the parentheses. Hit on Shift Enter. If it doesn't show you off as any errors, that means it is working properly. Now, if you want to check in the data types, type in print, open parentheses, df dot dtypes. Close off the parentheses and hit on Shift Enter. Now you can see that we have the age turned into an integer value. The salary is already an integer, and the join date is now a date time format. Okay. And still you can see we have the object over here, which is dtypes, but still you can see we have integer, or we have converted these data into an integer format. Now, why does it matter in data analysis? It ensures that correct mathematical operations, an example like converting string to number or converting number to strings, is done. It also enables time-based operation, such as filtering data with a certain date. It also helps to avoid errors in data visualization and also modeling in the same time. You will also be able to use float, category, or error coerce. So now we have done the basics. Now the next thing that we're going to learn about is more of an advanced feature, such as converting to float values,
converting to category, and also handling conversion errors using errors equal course. First off, what we want to do is we want to add some new columns for demonstration. Let's put in df, secondary brackets. Let's put in the height. Close off these secondary brackets, equal, secondary bracket over here. I'm going to put in 5.8, comma, 6.1. And then I'm going to put in another one, let's say 5.5, comma. That's what you want to put in, or this is already identified as string floats. Then I'm going to define in df, I want the department for every one of them. So here I'm going to put in department, close off these secondary brackets, equal. Here I'm going to put in single quotation HR, comma. I'm going to put in finance, comma, and then I'm going to put in HR over here again. Well, this is basically a categorical data. Then I'm going to put in df, and then I'm going to put in experience. Here, I'm going to put in equal, secondary brackets, let's say 2. Then I'm going to put in 3 like this as a string value, and then I'm going to put in 4 like this. Now I'm going to put in print df. Now you can see we have the age, salary, join date, height, department, and also experience. Now, the first thing that we want to do is we want to change these float values of 5.8, 6.1 into string. Okay? So first things first, what I have to do over here is I'm going to type in df, and then I'm going to type in the height to validate it, df, and here I'm going to put in the height value again, close off the secondary brackets. I'm going to type in as type, then open up the parentheses, and then I'm going to define it as float value. So close off the parentheses and hit on Shift Enter. If I print out the value again, df, and now you can see it will turn into let's say a float value. Okay, so all of these are basically a string right now, but now it will turn into a float value. You can check the d types, df, or let's say df dot d types, and now you can see if I check the height, there is a float value. But if I did not do this, it wouldn't have shown me. Let's say I'm going to cut this off. Now you can see we still have that because it is already working properly. Okay, so let's just paste it over here and keep it like this. Now, we're going to convert the department into a category. So you can see the department is an object. So if you want to change that into a category, I'm going to put in df. Here I'm going to put in department equal df department. Let's open up the secondary bracket over here, dot as type, then open up the parentheses and define it as category. Close off the parentheses, and that's it. Now you want to print it out, so type in print df dot dtypes, Shift Enter, and now you can see the department has turned into a categorical data. Now, if you want to convert the experience to numeric with errors or coerce, what you basically have to do is you have to put in df, then I'm going to put in experience equal df, what we do most times, but I'm going to use pd to then put in underscore numeric, which is going to turn this data frame into numeric values. So df, secondary brackets, define in the experience. Close off the secondary bracket over here, comma, error equal, then put in coerce. Close off this. This is how it is going to look like. Hit on Shift Enter. Then type in df, or let's say print df dot dtypes. And now you can see
this experience has also turned into a float value. But you can see over here, it was an object. So, but if you tried putting it the exact same way that I have turned this experience into, you will see an error because there is this string value inside. Okay, so now you have converted this string over here also into a float 64 value. Okay, so this will convert valid numbers to integer or float, and invalid strings like tree will be turned into NaN in most times. But in the newer version, it will turn into a numeric value. So if you obviously want the end result, type in print, type in df, and then type in print, open up the parentheses, double quotation, put in a backward slash, n data types, colon, and put in backward slash, n double quotation, comma, df dot dtypes. Close off the parentheses, and now you can see everything will be appearing over here. Like this, you can see the department HR, finance HR, experience has turned this 2.0. We have NaN like error and also 4.0 over here. Okay, and you can see we have the integer value. This one is also integer value. Join date has turned into a date and time format. Height is into a float value. Department was a categorical value, and it has turned into a float 64 value. Okay, so this is basically how simple it is of how you'll be able to convert data types. Okay, now the next thing that we're going to learn about is cleaning a messy data set. Cleaning a messy data set can sometimes be kind of, confusing. So first off, let's save up this file and let's go off and open up another file. New, and here I'm going to name it cleaning messy data set. Okay, so first off, let's import the necessary modules. Import pandas as pd, import numpy as np. Now the next thing, let's create a messy data set. Let's put in data equal, start off with the name, Alice, Bob, Charles, David, let's say Alice again. Here, I'm going to put in a none on Charles. If you're putting none, you don't have to put any quotation. Just define in none. Now, the next thing that I want to define is the age. Here, I'm going to put in a string value, 25, 30. Then I'm going to put in 35. Then I'm going to put in none in the same way. And then I'm going to put in single quotation 25. Close off these secondary brackets and close it off with a comma. Salary. Here I'm going to put in, let's say, 50,000. Then I'm going to put in 60,000. Then I'm going to put in non-value, 55,000, and then 50,000 again. Now the last value that I want is the join date. Or I can put in just join date like this. Here I'm going to put in single quotation 2025-01-01. Close it off. Then I'm going to put in, let's say, not available. That is how you want to put it. I can also type in just how it is. Then I'm going to put in 2025-05-01. Then I'm going to put in, let's say, 2025-11-01. Then I'm going to put in 2025 dash, let's say, 05-09. Okay, so we have one value, 2 value, 3 value, 4 value, and 5 value for 5 of these people. Now, another thing that I want to make sure is that it is the same because Alice is the exact same person. And that is exactly how I want to keep it. So if we're done, close off the third bracket. I'm going to put in df equal pd dot data frame define in data. Then I'm going to put in df. Now, one thing you can see, there is this double comma over here. So it is the salary. So let's just change this. And now you can see this is how it is going to work. There's an NaN error. You can see not available. And obviously there are a couple of places where it doesn't show me any data. So the first thing that you want to do is you want to view the data summary. For that, we use the info function. Put in df dot info. Now you can see we have the info and the summary of that. Range index 5 entries, 0 to 4 entries. Data columns, total 4 columns. Column age, like name, salary, join date. 4 non-null, 4 non-null. We have 4 non-null and 5 non-null. Okay, we have the object, object floats, and object. Okay, so we have 1 float value and 3 object values. Okay, so the next thing that we want to do is we want to describe all. I can also put it over here, put in df describe. Describe and open parentheses, and I want to include all of these values. So put in all just like this and close off the parentheses. In that way, it will show me off the mean value, the frequency, the top value, the unique value, the count, minimum, maximum, and also 25, 50%, 75%, and all of these values at the same time. And now you can see Alice is at the top because there is 2 of these values in the same time. Okay. Now the next thing that we want to do is we want to check for missing values. For that is quite simple, and I've shown you in my previous class. Put in is null, open parentheses, dot sum, open and close off the parentheses, and hit on shift enter. Now you can see we have 1 like error value, age 1 error, salary 1 error, join date does not have any error, and we have all of them as integer 64. Okay, now what we're going to do is we're going to fill or drop the missing values. First off, I'm going to start off over here, df. Let's say I want to fix the age value. Let's say I'm going to close it off, secondary bracket equal df age. Here, after the age, I'm going to put in replace, open up parentheses. Let's put in 30, and I'm going to put in a comma over here and put in np.nan. Close off the parentheses, which basically fix the invalid entry. The next one that I want to do is we want to convert to numeric. So I'm going to convert this age into numeric. Close off these secondary brackets equal pd.to underscore numeric, open parentheses, df, then open up the secondary brackets. Let's put in the age value, close off the secondary brackets, comma, errors equal, single quotation, coerce, close off the parentheses, which basically converts it to numeric. Then we're going to fill in the missing values with mean. So put in df age, secondary brackets equal df secondary brackets, here defined in the age value. Now after this, you want to put in as fill na errors or na values on the df. Here I'm going to put in age again, secondary brackets, and then put in the mean values inside. Okay, which basically fills in the missing values with mean values. Now we're going to fill the missing name. So put in df. Here I'm going to put in name equal df name. After that, put in dot fill na. Then open up the parentheses and put in unknown. Close off the parentheses just like this, which basically fills out the missing name. And then we're going to do the same thing with salary. So here I'm going to put in a method fill, or let's say a forward fill. So in that case, df, then put in salary, close off the quotation, put in equal df, then quotation, salary, close it off, and then you're going to put in dot fill NA and put in the method. After the method, put in equal, and then put in single quotation f fill. Close off the parentheses, which basically fills the salary with using the forward fill. Now, one thing that I've shown you is that if you use this method, it is not going to work for future errors. In that case, what you want to do is you want to close off up till this one and just type in ffill. That's basically all that you want to do, and close off with the parentheses. Okay, hit on shift and enter, and that's all that you need to do. So after that, it is going to fill or drop the missing values. Now, the next thing that we're going to do is we're going to convert the data types. To convert the data types, I'm going to put in df, secondary brackets, let's say join date. Secondary bracket over here, put in pd to underscore date time df, single quotation. I'm going to put in join date and close off the secondary brackets, put in comma, errors equal course. Make sure to put in a single quotation on both ends and close it off with the parentheses. Hit on shift enter. If it doesn't show you off any errors, then you are good to go. Then we're going to remove the duplicates. So here, df equal df dot drop underscore duplicates. That's all. Hit on enter or shift enter. And the last thing that I want to do is we want to print out the value, such as df. That is how it should look like. You can see this is how it is. If it doesn't show you off everything, it is totally fine. First things first that we want to do over here at the end is that we want to put in more values. Over here, I'm going to put in the data types. So type in print, open parentheses, df dot dtypes. Then hit on shift enter, and there you can see now we have Alice, age 25, salary 50,000, join date this one, and this is an object method. You can see name is an object, the age is float 64, salary is also float 64, and the join date is NS. And another thing that you can see in the name, we have unknown, which was already changed right over here. And also, all of them has basically turned into numerical values, which was not a numerical value at the beginning. Okay, so that is basically how it is. And this is basically how you'll be able to work with data analysis and cleaning a messy data set. So most common data set cleaning tasks are drop NA, which helps you to remove the missing data. Then we have fill NA, which fills out the missing values. We also use AS type or PD to date time, which converts the data types. When you put in drop duplicates, it removes the duplicates from your array or your data set. When you put in replace or apply, it fixes the wrong data. When you put in rename, you'll be able to rename any of the columns of the category. And when you put in str strip, it basically strips the white space off from any part of your array of data, or let's say your data set. Okay? So thank you for watching this video up till the very end, and hope you understood about everything in this class. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime, as I'm always there to help you out. Now, one last optional thing that I want to show you is using the rename function. In that case, let's put in df, let's say df dot rename. Okay? Open up the parentheses, let's say columns, equal, open up the third bracket, let's say we have the name over here.
In that case, instead of using the word name, I'm going to put in, let's say, first name. Close it off, comma. Then we have is, let's say, we have something over here as salary. So instead of salary, I'm going to change it out. So let's just change it to salary, colon, comma. Here I'm going to put in salary, and then I'm going to put in a dollar function, or let's say just a dollar over here. This is how I want to put it. In that case, close off the third bracket and also the parentheses. And then in that way, it will show me how it is. There you can see we have the first name and also salary as the dollar sign right over here. Okay, so thank you again. Make sure to practice all of these things, and I'm also going to be having all of these files in my resource folder so you can check it out. You can try the copy pasting methods, and if you still find any errors and complex parts, feel free to ask me anytime. I'm always there to help you out. Another thing that you can do is you can just copy all of these codes that you are using in your own snippet or in your own file. Or what you can do is you can take a screenshot and upload it onto our panel so that we can check where you are making the mistake. Okay, so thank you again. And without any further ado, let's move on to our next class of data analysis with Python. Welcome to a new class of data analysis with Python. In this class, we're going to learn everything about EDA and data distribution. Well, before getting into our practical part of this class, we're also going to get through some explanation of what EDA is. So, without any further ado, let's open up the folder and let's open up Jupyter Notebook on our device. As we have opened up the folder, let's go off OpenCMD and type in Jupyter Notebook. Let's wait for a bit until Microsoft Edge, or let's say your browser, which uses Jupyter Notebook to open up, opens on your device. Now, after this has been opened on my device, I'm going to click on New, Python 3. And after that, what we're going to do is we're going to name it EDA. That's all. So now we're going to understand about EDA. The full form of EDA is exploratory data analysis and understanding the data distribution. Well, what is exploratory data analysis? EDA is a process of exploring and summarizing dataset to understand the structure and contents of the data. You can detect patterns, trends, or anomalies using EDA. You can find relationships between specific variables, and you can also prepare data for modeling. There are common EDA tasks, such as viewing data structure such as head, info, describe. Well, I've shown you that on the most previous class of data analysis with Python. Checking for missing or duplicate values is also a common work for EDA. Visualizing data in histogram, box plots, scatter plots is also a work of EDA. And understanding distribution and correlation is also one of those common tasks. So first things first, what we need to do is we need to import the necessary libraries, such as I'm going to import pandas as PD. Let's take this over here, PD. I'm going to import matplotlib.pyplot. This is how you want to keep it, pyplot as plt. Make sure you keep it matplotlib, okay? Then I'm going to put in import seaborn as SNS. Now, all of these important, libraries have been imported on my workspace. Now, we're going to load the data set.
In this class, I'm going to be using the iris dataset again. So here, first off, define the data frame sns dot load underscore data set, open parentheses, double quotation, and name it iris, which is the exact same file that we want to open up. Now we're going to get the first 5 lines of the iris dataset. So type in df, then put in dot head and open it up. If it shows you off the data, then it means it has detected up the file and now it is working properly. Now the next thing that we want to do is we want to understand the structure. To understand the structure, you need the information and you want what type of data it is being used. In that case, put in df.info. I'm going to close off this line. There we go. We have the information of the data frame. And now you also want what type of data is being used for each column and row. So here df.describe, open and close parentheses. And now you can see we have the count value, mean value, standard value, minimum, 25%, 50%, 75%, and also the maximum, or let's say the 100% of the whole data. Now, as we have understood the structure right now, the next thing what we can do over here is we can check for missing duplicates. So to check for missing duplicates, put in df dot is null. Is null, open and close off the parentheses. It is going to show me off where it is, there. But I can put in dot sum to get out the whole value. And now you can see all of them are mostly 0 and all of them are integer values. If you want to check for duplicates, put in df dot duplicated. Now I'm going to open and close off the parentheses and put in dot sum. Now you can see there is only one duplicated value. Now the next thing that we can do is we can visualize the data distribution, which is the most important part. Such as we're going to, let's say, represent a histogram. In that case, first off, I'm going to put in the data frame and type in hist. Open up the parentheses, now define in the figure size. So type in fig size equal, open parentheses, let's say 10, 6. That's all that you're going to put and close off the parentheses. Now I'm going to put in PLT. So it is going to use matplotlib. And then I'm going to put in tight layout. There we go. And after that, I'm going to open and close off the parentheses. I'm going to put in PLT dot show. Hit on shift and enter. And now you can see we have the histogram by using the tight layout. You can also use loose layout if you want to. But this tight layout basically gives you off a better idea about what type of data is being used. Now, the next thing that we can do is we want to detect the outliers. For that case, I'm going to be using box plots. And whenever you are working with box plots, you have to make sure you work with Seaborn. So for histogram, you have to put in matplotlib. And for box plots and pair plots, you have to use Seaborn. So to work with box plots, put in sns dot box plot. This is how you want to keep it. Then I'm going to define in data equal df and then close off the parentheses. And then I'm going to put in plt dot show. Now I'm going to open and close off the parentheses and that's it. Hit on shift enter and now you can see we have the box plots. You can get more info out of it, but I'm just going to keep it this simple because, this is how it should work. Now, the next thing that I'm going to be showing you is about pair plots, which is the relationship between variables. In that case, we're also going to be using SNS. Put in SNS dot pair plot, open up the parentheses, put in a df, comma, q equal species, and then I'm going to close off the parentheses, put in plt dot show, and I'm going to keep it like this. Hit on shift and enter and then wait for a bit, and then you will see like various types of pair plots, relationship between variables will appear on your screen. And I've already shown this part in one of my previous classes. So if you did check out my previous classes properly, then you should remember where I have used it and how I, represented it on my screen. Now, the next thing that I'm going to be showing you is about the heat map. It is basically the correlation between the variables. Now, also for a heat map, you're going to be using Seaborn. So type in sns.heatmap, open up the parentheses, and define in df.corr, open and close off the parentheses. I'm going to define anot equal true. After true, put in comma, put in cmap equal single quotation, cool warm. Close off the parentheses. I'm going to put in plt dot show. Open and close off the parentheses and hit on shift and enter. And then wait for a bit. And now you can see in some cases, it might show you off as an error. So we're going to check out which part we are messing it up. So I'm going to check off for heat map, sns.heatmap. After that, open up the parentheses, df. We have this data frame dot correlation. We have a comma, anode equal true, cmap equal cool warm. Well, almost all of them are true. So what we're going to do is we're going to cut this off. So now you can see that it did not work. So I'm going to fix up my code a bit, because one thing you can see over here is there is this, and there is also a string value inside. In that case, I'm going to include only numbers, so numbers are validated. So I'm going to type in numeric underscore df equal df dot select underscore dtypes, open up the parentheses. I'm going to type in include equal numbers. Close off the parentheses. And then I'm going to do is I'm going to draw the heat map. So type in sns.heatmap. After that, open up the parentheses, put in numeric underscore df correlation. df.corr, and open and close off the parentheses, put in comma, anot equal true. I'm just going to close off one of these commas as we have true over here, comma. I'm going to put in cmap equal cool warm. Now I'm going to close off the parentheses at the end, just like this. I'm going to put in plt dot title, open up the parentheses, and here I'm going to put in correlation of, or let's say correlation heat map of numeric feature. That is going to be the title. Close it off, and then I'm going to put in plt.show. You can see it might show you off as a couple of errors sometimes, but what you can do is you can just cut it off and you can paste it back again. So here I'm just going to paste it back again, hit on shift enter, and now you can see it is working properly. You can see we have the correlation heat map of numeric feature, we have the lengths and widths, and we also have this heat map at the side. Okay, so this is basically how you are going to find the heat map or the correlation of the data frame. Now, the next thing that we're going to learn about is understanding the data distribution, which is knowing how data is spread helps us to decide which statistical or machine learning technique to apply. In that case, we're going to start off with plot distribution for a feature. In that case, we're also going to be using Seaborn, let's say histo or hist plots. Open up the parentheses, put in df, then secondary brackets. I'm going to put in sepal length, close off the secondary brackets, put in comma kde equal true. Close off the parentheses. I'm going to put in plt dot title, and after that, open up the parentheses. I'm going to put in sepal length distribution. Okay, close off the parentheses, plt dot show. Now you will see that we have the sepal length distribution done on our screen. Okay, if you want, the sepal width, you can also do the same thing. I just have to put in width over here, and here I'm just going to change this title to width. There we go. Now we have the width. In the same way, you'll be able to do the same thing for each and every one of them. You just have to basically change the name so it meets up with the criteria. Let's say if I put in petal width, I'm going to put in petal over here. And there we go. Now we have the petal width distribution. Okay. Now the next thing that we're going to do is we're going to check for normal distribution of data. Now the normal distribution of data is also quite the same. So here I'm going to put in from scipy dot stats import Shapiro. If it doesn't import up, what you can do is you can install it. Now another thing that you can do is you can check it out, and I'm going to put in Shapiro, and there we go. We have changed it, and now it is validated. So as this is validated over here, what we're going to do is we're going to put in more commands. Let's say the stats, comma p equal Shapiro, and here I'm going to put in open the parentheses df, then put in secondary brackets. I'm going to find out the sepal length. We have the sepal length, and then I'm going to make sure to close off the secondary bracket first, and then the parentheses, and then I'm going to print out the data, open parentheses, Shapiro. Here I'm going to put in Wilk test colon p dash value equal, that's it. And here I'm going to put in comma p. Close off the parentheses and hit on shift enter. And now you can see Shapiro Wilk test p value equals 0.0101881. Okay. Or the normal value is most of the time 0.05. Okay. Now the last thing that we're going to learn about is using skewness or kurtosis. In that case, what we're going to do is we want to put in print, open parentheses. Here I'm going to put in skewness, quotation close, comma, data frame, single quotation, sepal, underscore. Let's say I'm going to put in the length, close off the secondary brackets, dot skew. That's how you want to put it. And the next thing is the kurtosis. So type in print, open parentheses. Here I'm going to put in kurtosis. Here I'm going to put in comma, df, secondary brackets. I'm going to put in the sepal length over here. Here I'm going to put in dot. As we put in skew, we're going to put in card over here. And that's it. If you hit on shift enter, we have the skewness value 0.03. And also we have the curd value, which is minus 0.5. So the summary of this whole class is loading data by using the SNS load dataset iris. Then we learned about the data info, which we already learned in my previous classes too, such as using the df info and the df describe. Then we visualized the distribution using SNS histplot, df, histogram, and also boxplot. We checked the normality by using Shapiro, skew, and curd, and in the same way, we got the relationships and we checked the relationships using pairplot and heat map. So, thank you for watching this class up till the very end, and hope you understood about everything in this class. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of data analysis with Python. Welcome to a new class of data analysis with Python. In this class, I'm going to be showing you every brief that you need to know and also the practical part of grouping and aggregation, which is group by, and also value counts and also unique values in data analysis. Now, before getting into the practical part, I'm going to go through them by explaining what these are in data analysis and how it helps you for data analysis. So make sure not to skip any part, and without any further ado, let's move on to our class by opening up Jupyter Notebook on our device. First off, we have the folder. Let's type in cmd and type in Jupyter Notebook. Now let's wait for a bit until it opens up on my device, and from there I'm going to wait until it shows me off the home screen. Now let's create a new file, and then let's name it. I'm going to be naming this groupby. Okay, so first off, you need to know about what is groupby, or what is grouping and aggregation. Well, in pandas, groupby is used to split data into groups based on some criteria, like categories or values in a column, and then aggregate those groups using functions like sum, mean, count, and etc. It follows the process of splitting the data, applying the function, and combining them together. In example, you can have a data set where you want to find a total value per region, or just hold it as an example. Now you can group the data by specific region and also apply the function or whichever one you need, in example like sum, mean, max, minimum, to get rid or even get the total value of according to your data or to your need. In that case, first off that you need to do is you need to import the necessary libraries. Import pandas as pd. Then the next step that we're going to do is we're going to get the data. So let's create the data. Here, I'm going to put in single quotation. Let's say here, I'm going to put in a region. Now, there's going to be specific region. Let's say east, west. Then I'm going to put in east again. Then I'm going to put in south. I'm going to put in north. That's all that I'm going to put. You can also put in more if you want to, but I'm just going to keep it just like this. And after this, I'm going to close it off with a comma, and then I'm going to put in the name. Here, for everyone, I'm going to put in a name. Let's say for east, it's Alice. For west, it's Bob. For east, again, it's Charles, comma. Then for south, I'm going to put in David. And then I'm going to put in Eva. Close it off. Then I'm going to define in the sales of each and every one of these regions. So in sales, I'm going to put in 200, 150 for Bob. For Charles, I'm going to put in 300. For David, I'm going to put in 100. And for Eva, I'm going to put in 400. Then I'm going to close off the third bracket, define in df, then put in pd dot data frame, open parentheses, data, and then I'm going to put in df like this. In this way, our data frame has been created. Now, the first thing that we want to do is we want to group the data by specific region. Here, I'm going to put in grouped as the variable. Here, I'm going to define the data frame and define in group by, and open the parentheses and define the region. In that case, the region is validated and it will turn into a grouped data by specific region. Here you can type in df, or you can type in print. Here you can type in grouped. And now you can see there is a core data object. Here you can put in df.grouped and it will still work like this. But here we have this grouped value over here. So you have to make sure you put in the exact same value. So df you can type this, and if it shows you off as an error, then it is totally fine because it cannot get the attribute yet, because we're going to be showing that to you by the end. Okay, so the next thing that I'm going to do is we're going to apply aggregation function, such as the total sales per region, average sales per region, and count of salespeople per region. In that case, let's define in the grouped value. Here I'm going to put in the sales over here, and then I'm going to get the total sales. So in case of that, I'm going to put in some open and close parentheses, and there we go. For the east, it is 500. For the north is 400. South is 100, and west is 150. If you want the average sales per region, put in grouped sales, secondary brackets, then put in the mean value. Close off the parentheses, and there we go. We have the mean value, or let's say the mean average sales per region. Now, if you want the count of salespeople per region, it is also quite simple. Type in grouped sales dot count. And there we go. For east, there is 2 people. North is 1, south is 1, and west is also 1. Now, the next thing that we're going to learn about is using the multiple aggregation at once. If you want to get all of these in the same time, what you can do is use aggregation or multiple aggregation. So put in grouped sales. Here I'm going to put in dot aggregation. Here I'm going to put in the sum value, comma, mean value, comma. I'm going to put in the max value and the minimum value. Secondary bracket to close it off, and also a parentheses which is start off before the aggregation, or let's say right after the aggregation. Here you're going to hit on shift enter, and you might see this type over here because I'm going to put in sales like this, and there we go. We have the east, sum is 500, minimum, like mean value, average value is 250, maximum is 300, minimum is 200. For north, it is 400, mean is 400, max 400, minimum is also 400. If you put in more values in each and every one of these regions, then it is going to change. Let's say I'm going to change a bit on the north. Okay, so after that, put in another comma. I'm going to define in north again, colon, and after Eva, I'm going to put in Darwin. Now here, comma, I'm going to put in 100. Hit on shift enter, and now you can see for north, there is the sum value 500, mean value is 250, maximum 400, and minimum is 100. So whenever you change out these values, it is going to change according to your data frame. Okay? Now the next thing that we want to do is we want to group by multiple columns. Let's say I want the region, I want the salesperson, and also I want to get the sales and I want to sum it up all together. In that case, what you want to do is put in df group by, open parentheses, secondary brackets, define in the region. After that, comma, here I'm going to put in the salesperson. After that, I'm going to close off the secondary brackets, close off the parentheses, and then define in the sales right over here. After that, you just want to put in a dot sum, open and close off the parentheses. Now this might show you off as a couple of error over here. In that case, what we're going to do is we're just going to, put it like this. And we have the salesperson over here, which is not working and it is not found. Okay, so you can see data frame, group by, object self, keys by, axis, level, and all of these. Key error is the salesperson. What we can do over here is we can try putting in sales. Now you can see that we have region sales, east 200, 300, 200 over here, 300 over here, We have north over here, we have south over here, and we also have the west over here, and the D type is integer 64. Now, as we have learned about how we can group by multiple columns, the next thing that we're going to learn about is resetting the index, which is totally optional. But if you want to convert the result back to a data frame with the default indexing, what you want to do over here is type in group by, type in sales. Here I'm going to put in dot sum, then put in dot reset underscore, put in the index. Open and close off the parentheses, and now you can see we have this group by as an error because we are using the grouped variable. In that case, this is how it will look like according to the index value. Okay, so the last step that you need to know about is sorting the result, which is also totally optional. But what you can do is you can group them up depending on the result and sort them out. So to do that, type in the variable which is grouped underscore sum dot sort underscore values. Okay, open the parentheses and type in ascending equal, type in false. Hit on shift enter, and now you can see this is how it is working. If it is a group sum, it is not going to work. But if you type in like that, grouped.sort values ascending. Now we're going to check the attribute error, which is data frame group by object has no attribute of sort values. So it doesn't have any sort values that we need to use. In that case, you are going to create another data frame, or let's say the sort values, which is going to work according to it. So here, what I'm going to do, first off, let's remove the sum. And sometimes when you keep it like this as ascending equal false, you can see if I hit on shift enter, now it is working properly. Now, if it still doesn't work in your case, then you want to type in grouped equal data frame dot group by. After that, you want to open up the parentheses. Now you're going to define it by region. So define in region, and then region is going to be connected with the sales value. So define in the sales, then put in the sum and open and close off the parentheses. After that, you're going to type in sorted group as the variable and type in grouped dot sort. After that, put in sort values over here, open the parentheses and type in ascending equal false. Close off the parentheses and then type in print sorted group. Hit on shift enter, and then it will also work the exact same way. So this is basically how simple it is of how you'll be able to use group by while data analyzing with Python. Now, the next thing that we're going to learn about is the value counts and also unique values in pandas. Well, value counts and unique values in pandas are super useful for exploring categorical data, like checking how many times each value appears in a column or what unique values exist. Now, another thing that we're going to show you in this class of group by is the summary. Okay, so in the summary, you can see that what we did over here is the first one, which is group by. Now, whenever you are using group by, it uses the array of data and groups the data by specific region or whatever category you are working with. So it groups it into a column. In that case, you're going to use group by. Then the next thing that we did over here as the sum, mean, and the count was applying the aggregation function. Now, when we apply in the aggregation function, we also need a variable created by the group by. In that case, we got the sales value with the group by, and then we applied aggregation function, and it also helped us to use multiple aggregation at once, which reduced the time and labor at the same time. Then the next thing that we did is we grouped it by multiple columns.
such as region and also sales. Okay, so both of them were connected together and we checked in what we get for specific region. And then what we did is we resetted the index. So now we can see it is 0, 1, 2, and 3. And the last thing that we did over here is we sorted out the data in ascending or a descending order. You can also put in the value as true. In that case, this is how it will look like. Okay, so that is it for this group by. Let's save it up and let's create another file right over here. Now the name of this file that I'm going to use, I'm going to put in value count and unique values. Okay, so as you now already know about value counts and unique values in pandas, first off, let's import pandas. As we have imported pandas, now let's create a sample dataset. Here, I'm going to start off with the city, secondary brackets. Let's put in New York, comma, London, comma. I'm going to put in New York again, Paris. Then I'm going to put in London again. Then I'm going to put in Berlin. Then I'm going to put in Paris. After Paris, I'm going to put in another Paris. Then after city, I'm going to put in the gender value. Here in gender, I'm going to start off with, let's say, male, comma, female, comma, female again, comma. I'm going to put in male, comma. I'm going to put in female. Here, I'm going to put in male again. After male, I'm going to put in female. And again, male. Now we're going to check how many times it has been applied. 1, 2, 3, 4, 5, 6, 7, and 8. There we go. So everything is done. Let's close off the secondary bracket. Now after the secondary bracket, I'm going to move on to the next line. And then I'm going to put in the data frame equal pd.data frame. Open the parentheses, define in data, and define in df. In that case, we will get all of these values as the output. Now, the first thing that we're going to do is we're going to use the value count, which is used to count how many times each city appears inside of the array or the data frame. You can see New York was 2 times, London was 2 times, Paris was 3 times, and Berlin was 1 time. But you don't want to count like this, because it's not going to give you a good time and it will take a long time if you have a big data set. In that case, define in the data frame, define in what you want to search. Let's say I want to search the city, how many times it has been applied. I'm going to put in value underscore count. There we go. Paris 3 times, New York 2 times, London 2 times, Berlin 1 time. Now, to count the gender frequency, do the same thing, but with the gender. So type in the gender dot value underscore counts. There we go. Male 4 times, female 4 times. If you want to use normalized true to get percentage instead of raw counts, what you want to do over here is type in df. Let's say maybe I want the gender value. Now gender dot value underscore counts, normalize, and then put in equal true. Now close off the parentheses and hit on shift enter, and there you can see male is 0.5 and female is 0.5.
In that case, both of them turns into 1, or let's say 100%. Okay, so this is basically how you're going to use value counts. Now let's show you how you're going to use the unique function to see all unique values. In that case, define in the data frame, secondary brackets, define in the city, close off the secondary brackets, and put in the unique value. Open and close it off, shift enter, and now you can see in the array we have New York, London, Paris, and Berlin. So these are the 4 data that was available inside of my array, or let's say my data frame. If you want to check the gender, df gender, secondary brackets, define in unique. This is how you want to put it. And there we go. We have male and female. And the object type is also, or the D type is object. If you had numerical values, then it will show you numerical values. You can also use NU unique to count the number of unique values. In that case, I'm going to put in df. Let's say I'm going to start off with the city, close off the secondary brackets, NU, and type in N unique. Okay, open and close off the parentheses. Now you can see city is 4 times. If you want the gender value, df single quotation gender and unique. So there are 2 unique values in the gender. So in the summary, what we can do is that the value counts count the occurrences of each value or each unique value that is available inside the array of the data frame. When we use value counts and normalize true, it basically finds out the percentage of each unique value. And when you use unique, it gets array of unique values. And when you use N unique, it counts the number of unique values inside of your array, or let's say your data set. So, hope you understood about everything in this class. And if you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So, without any further ado, let's move on to our next class of data analysis with Python. Welcome to a new class of data analysis with Python. In this class, I'm going to be showing you everything that you need to know about simple narrative using Markdown and code. Now, why are you going to be using this in data analysis? Well, the goal is to create a simple data analysis project by combining the Markdown cells for storytelling, code cells for Python data analysis, and simple visualization and a clear beginning to end analysis. And there are a couple of steps that we're going to be doing in this class. So, without any further ado, let's move on to our class by opening up Jupyter Notebook on our device. As you can see, I have opened up my folder. Let's open up CMD. Let's type in Jupyter Notebook. Now, as this opens up on my browser, we're going to start off by creating a new notebook. So let's wait for a bit until this opens up just like this. Now, as this has opened up, let's click on New and create a new Python file. Here, I'm going to put in simple narrative with Markdown and code. Okay, so the first step is adding a Markdown cell, which is going to be the title and the introduction of this whole class. So first off, you want to start off with the hash command. I'm going to put in analyzing students, let's say performance dataset. Then I'm going to put in this notebook, we will perform, or let's say explore, a dataset of students' exam scores. Now, I'm going to put in will find patterns and insights using Python libraries like pandas, matplotlib, and you can also use Seaborn and also so on. Here I'm just going to put in and Seaborn. Hit on Shift and Enter, and this is how it will look like. If it looks like this, it is totally fine. Now, one thing that we're going to do over here is we're not going to be using this one over here. So let's just create this and let's just paste it over here. And you're going to hit on Shift Enter. Now, it will also show you something like this as an error. You can add it up more and more, but it will just keep on coming up just like this. Here I can create a duplicate. In that case, you'll be able to create a duplicate just by clicking on this button. Here you can play this command and you can see that it is still working like this. Now, if it opens up like this, it is totally fine. And it is obviously going to show you an error. So here, what you can do is you can put it just like this. Now you can see in this notebook, and there we go, we have this invalid syntax. If it shows you off like this, just press on Ctrl X and just paste it over here. Now, the next thing that I'm going to do is I'm going to click on Insert Another Cell. I'm going to paste it at the bottom. Here, I'm going to click on this and paste it right over here. In that way, you will see that it will be pasted right below this cell. Now, the next step that we need to follow up is the code cell, which is where I'm going to import the libraries. So type in import pandas as PD, import matplotlib.pyplot as PLT, import Seaborn as SNS. Then what we're going to do is we're going to display the plots inline. In that case, put in the percentage over here. Then type in matplotlib inline. Now you can see that there is no such error. If you don't see any specific errors, that means it is working properly and it is also displaying the plots inline. So the next thing that you can do is you can load the dataset. Now, I have attached in this folder, or let's say this file over here, named studentsperformance.csv. So let's open up this one, or let's say our Jupyter notebook. Here I'm going to put in data equal pd.read_csv. Here I'm going to just paste in the exact same name. So what I can do over here is I can copy this whole thing, Control C, and I can paste it right over here. Close off the parentheses, and here I'm going to put in data.head, Shift Enter, and there you go. You can see this is the exact same file that we want to use. Now we're going to get into the Markdown, such as describing the dataset. Now, there are a couple of markdowns that you can do over here, such as if you want markdowns to put in 2 of these hashes, I'm going to put in dataset description. After that, I'm going to put in this dataset contains information about students' performance in 3 subjects. Here, I'm going to put in dash math dash reading dash writing. Here, I'm going to put in each student entry also includes gender, race, let's say ethnicity, comma, parental education, comma, let's say lunch. After lunch, I'm going to put in basically everything there is inside of this data set. Let's see here, I'm going to put in lunch type and test preparation course. Now, if you put in Shift Enter, it might show you off as an error. Now, the easiest method of changing this into a Markdown is that you have to select on this first, click on Code, and click on Markdown. Now, if you hit on Shift and Enter, this will show you off as Markdown. In the same way, we're going to change it to Markdown and hit on Shift and Enter. And there we go, analyzing students' performance data sets. We have the import, all of these, and this is how it is going to work. Okay, so basically you just have to change it whenever you are doing Markdowns in these cells. Then what we're going to do is we're going to describe it. So here I want the basic statistics of this specific data set. Data dot describe, and there we go, we have the data set over here. Now the next thing that I want to do is we want to mark down the highlight observations. In that case, click on Markdown over here, and here I'm going to put in hash observation. Here I'm going to put in dash average math score is around 66. I'm going to put in dash. I'm going to put in there is some variations across subjects. Then I'm going to put in dash. Let's now visualize the score distribution. Here, I'm going to put in this colon over here, hit on Shift Enter, and there you go. You can see, there we go, we have our Markdown. Now, as we're getting into the visualization, you have to use SNS, which is Seaborn, and also Matplotlib. In that case, first off, put in SNS. I'm going to define in histplot. Here, define in the data. Let's say I want the math score first. So here I'm going to put in math score. I'm going to put in comma, bins equal, I want 20 bins. KDE is equal to true. And I want a color, which is sky blue. Okay, close off the parentheses. Here I'm going to put in sky blue, just like this. Then I'm going to put in plt dot title, double quotation, distribution of math scores. Here I'm going to put in plt dot xlabel, double quotation, score, close off the parentheses, plt dot y label right over here, y label. Now I want the frequency, double quotation, close it off, and here I want to show off the whole thing. plt dot show. Shift and enter, and now you can see it is showing me as an error because we're going to change this to double quotation, and there we go, we have the frequency over here in histplot. It is mainly also using Seaborn, so if you did not import Seaborn at the beginning, it's not going to work. Even if you do not have Matplotlib, it is totally fine because still we are using histplot by using the base of Seaborn. Now the next thing is code cell, which is about group analysis. In that case, first off, I want the average score. Average underscores. Here, after scores, I'm going to put in by the gender. So here I'm going to make sure I do it by gender. Data dot group by, open parentheses, gender, close off the parentheses, secondary bracket 2 times, say math score, comma, reading score. After the reading score, I also want the writing score, comma. After the writing score, I'm going to put in dot mean. After we get the mean value, it is basically going to get the average value. Then here I'm going to put in average scores by gender. Hit on Shift Enter, and now you can see there is an error because we put in 2 of these. Now you can see there is another error, which is basically getting it by writing score. So if it cannot find the writing score, let's check out the data. Here we have the race, math score, reading score. We have the writing score over here. So one thing that we're going to check is the writing score. If it is matching up, writing, and then we have score. There we go. We have the same thing, but it is still showing me off as an error. So let's just copy this and let's just paste it at the end right over here. There we go. Now you can see for the female, it is 63%. Reading score is average of 72%, and writing score is average of 72%. For males, the average score of math score is 68. For reading, it is 65, and for writing, it is 63. So that means even on average, the male is a bit lower than the female average scores. Now, the next thing that I want to do is using a Markdown. So let's put in Markdown, and here I want the inside values. In that case, I want it on gender basis. So here, gender based average scores. Here I'm going to put in from the table above, we observe. After that, I'm going to make these lines. Let's say males tend to score higher in maths. Let's put it in capital, math. And females tend to perform better in reading and writing. There we go. We have the gender basis average scores. Now the last thing is basically the conclusion, which should also be in a Markdown cell. Here we have a Markdown. So let's keep it on Markdown over here. And let's put in the conclusion. Here, I'm going to put in there's a clear pattern in performance based on gender. Here I'm going to put in preparations. Courses seem to improve scores, and then I'm going to put in visualizing data helps understand hidden trends easily. So I'm going to put in the same thing, understand hidden trends easily. Here I'm going to put in this was a basic walkthrough. More analysis can be done on correlation, performance, and so on. So you can see this is basically how it is going to look like when you put in Markdown and also codes in the same file. It looks a lot more organized, and as it is more organized, it looks more professional and can be presented in a professional manner too. So the summary is that by combining the Markdown for narrative and Python code for execution, your notebook becomes more informative, has a bit more information to it. It is a bit more structured and it is easier to understand. Okay? So this is basically all for this class and hope you understood about everything in this class. If you still have any confusion or any question about any part of this class, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our last class of data analysis with Python. Welcome to our last project of this course. In this part of this course, or in this class, I'm going to be showing you the example of Capstone Project. Well, the Capstone Project is basically the project about analyzing COVID-19 global data. So if you followed up to my previous classes up till now, then it is going to be very simple for you to work with the Capstone Project. So let's just hop onto our class by opening up Jupyter Notebook on our device. First off, let's create a new notebook. And here in this notebook, I'm going to name it Capstone File. First things first, you want to import the libraries. Import pandas as pd, import numpy as np, import matplotlib.pyplot as plt. I'm going to import sns as, or let's say seaborn as sns. That's all that you need to do. Then we're going to load up the dataset. The dataset is also in my folder. You can try using that. Read underscore CSV. And then here, I'm going to put in the exact folder. Here, this is the exact file that you want to work with: coronavirus, summary, and daily data. You can use whichever one you prefer. Let's say I'm just going to copy and paste this exact same one. There we go. So as we have that, let's put in df.head. Now you can see there are a couple of errors that might show off on your screen. So let's check out error number, no such file directory, world meter, coronavirus summary data. Let's open up the file again and let's check out if this is a CSV file. Okay, if this is a CSV file, we're going to copy the whole thing, Control C, and then we're going to paste it over here. There we go. Now you can see we have the data on our screen. Now let's clean up the data by handling the missing values and converting the data types. So here, df.isNull.sum. Here I'm going to put in df.fill NA, open parentheses, 0, in place equal true. Then I'm going to put in df, then put in the date, put in equal ed.to_date time. Here I'm going to put in the data frame again, and let's define it with the date. Okay. Another thing you can see, we have put in two of these. So let's hit on Shift and Enter. You can see it is not working because we have put in the date over here. Now, if it doesn't work with the date, it is totally fine, because first things first that we need to do is we need to find out the data. In that case, let's open up the file again and let's use this. Let's just copy the whole thing, Control C, and let's try pasting it on this file. Now you can see it is still showing me off as an error because it cannot find the date. In that case, I'm just going to turn this into lowercase and it will take a bit of time. And if it doesn't show you off any error, then it means it is working properly. Now, the next thing that you want to do is you want to explore the data analysis, such as EDA, describing the data and finding the trends. put in df describe, and here I'm going to put in df country. Here I'm going to close it off with the secondary brackets. Over here, put in dot value pounds. I'm going to put in dot head. Now I want 10 of these lines in my head. So you can see it is still showing me off as an error because there is no country. So let's also turn this into small letter, as this is small letter. Okay, in this case, we got the first 10 of these countries, and we have the casualties, which are over here, and we also have the name of these values. Now, as we have found the trends, now we can visualize the data one by one. You can also see there is a specific date over here. So here, I'm going to put in top countries equal df. Here I'm going to put in df again. Let's say the date double equal, let's say single quotation 2021-12. I'm going to put in 31 in that case. Single quotation to close it off. I'm going to put in group by, open parentheses, country, close off the parentheses. I'm going to put in confirmed, secondary bracket to close it off. Let's close off one of these secondary brackets as we're not needing that. And after that, we have confirmed it. Now I'm going to put in dot sum. Here I'm going to put in n largest. I want the fifth of them. Now you can see it is still showing me off as an error because we have used this capital over here. And now we can see column not found as confirmed. So one thing that I want to do is we want the active cases. So let's just copy this. Instead of confirmed, I'm going to put in active cases. Now you can see there are no specific errors. Here, what you can do is you can put in the PLT. But after that, I'm going to put in top countries. Here, I'm going to put in the plot value. After the plot, let's put in the kind of the plot that we want. In that case, kind equal, I want a bar plot. So let's put in as bar, comma, title equal, I'm going to put in top 5 countries by confirmed cases. Here I'm going to put in plt dot y label, open up the parentheses, confirmed cases. plt.show to show up the top 5 countries and the confirmed cases. Okay. Now, if you want to ask and answer key questions, you can find in the debt rate. If there is any, you can see cumulative total debts. So here I'm going to work with cumulative total debts. Put in DF, secondary brackets. Here, I'm just going to copy this. Control C, paste it. Close off these secondary brackets equal DF. Put the same thing right over here as debts. If you want to work along with it, you can put it just like that. I'm going to close it off as debts. And right after debts, close off these secondary brackets slash DF, secondary brackets. And here I'm going to put in the active cases. I'm going to find it out with the active cases. And then I'm going to hit on Shift Enter. Now we're going to wait for a bit. If it doesn't show you off any error, then it means you're good to go. So here I'm going to put in the highest debt rate equal df dot group by. I'm going to put in the country value over here, close off the parentheses. I'm going to put in the active cases if you want to, but I can also put in the cumulative total debt. So let's copy this, paste it over here, secondary brackets, and I want the mean value. So here I'm going to sort it out under values. And then I'm going to fix it out if I want ascending values or descending values. And here I'm going to put in ascending equal false, so it's not going to be correct. And then we're going to visualize it using the data frame. So here I'm going to put in the highest death rate. Here I'm going to put in dot head, hit on shift and enter. You can see there is a lot of these cases, and it is the cumulative total deaths, and the type is float 64. If you want to get into the summary and conclusion, you have to use a markdown. And if you want to export the final report, what you can do is put in df2 underscore CSV. Here I'm going to put in the COVID-19 analysis cleaned.csv. Close it off with the parentheses if you want to, but here you're going to put in the index value equal false. In that case, it is going to work better. And if you open up the file over here, there's going to be another file named the COVID-19 analysis cleaned. Okay, so this is basically how you're going to work with the Capstone project. So in this course or in this class, we have learned about the key concept using groupby, plot, fill an A, and date time. We worked with libraries involved with pandas, matplotlib, and also Seaborn, and we also checked in on real-world value of the insights that you have found. So thank you for watching these videos, and let's move on to our class project. Welcome to class project 1. The name of the class project is building a short report. Now, in this class project, I have applied or attached in a description and also an outcome. So before getting into these steps, let's learn about what we're going to do in this class project. This class is designed for beginners who want to explore the real world data using the powerful tools of Python in a Jupyter Notebook environment. So let's get into these steps. The first step that you want to make sure to complete is import the specific libraries. Now the libraries could be pandas, numpy, seaborn, matplotlib, and so on. The next step is loading and understanding the data, such as info and the description. In step 3, we're going to clean and prepare the date or whatever data there is. Then the next thing that we're going to do over here is we're going to analyze and visualize the data using specific libraries and also specific functions. In step 5, we're going to draw insights and we're going to conclude this class project. So what is the outcome of this specific class project? By this class project, or by watching this class project, we're going to know how to operate in Jupyter Notebook settings. We can use pandas to load and examine datasets. We can determine and deal with inconsistent or missing data. We can make simple plots and visualizations using matplotlib and Seaborn. We can get insightful information from data using structured analysis, and we can independently apply the 5-step data analysis framework to additional datasets. So, after knowing all of these steps and also learning about how you can do and complete these steps, you'll be able to apply them in future purposes too. So, let's move on with our class project by following and also opening up Jupyter Notebook on our device. First things first, in this folder, let's open up CMD. And then here, I'm going to type in, let's say, Jupyter Notebook. Hit on enter, and let's just wait for a bit until this whole process has been done. Now, after this process has been done, you can see I have opened up, or let's say, this web browser opens up on its own. Now let's click on new and let's open up another notebook. Now this notebook, I'm going to give it a name. Let's say I'm going to put in build short report. That is going to be the name. Now, there are a couple of things that we want to know about. As we're going to analyze the data, now we're also going to need a test data or a sample data set. So let's say in this case, we're going to be using the Titanic data or the passenger data from the data set of Seaborn. In that case, first off, let's start off with importing our libraries. First off, import pandas as PD, import numpy as np, import seaborn as sns, import matplotlib dot pyplot as plt. Now you can see we have started by importing all the necessary libraries that we need in this specific class project. Now let's move on to step 2, which is loading and understanding the data. To understand the data, first off, we have to load the dataset and take a look at its structure. First off, define in the data frame. Now, as we're going to be using the Titanic dataset, let's put in SNS, load underscore dataset, and then put in Titanic. In that case, now let's display the first 5 rows if it is working. df.head. Now you can see we have loaded up the Titanic dataset, and also we have accessed our dataset and it is working properly. So basically we're using Seaborn's built-in Titanic dataset, and .head helps us to preview the top rows to understand the data. In step 3, we're going to clean and prepare the dataset. So basically we're going to check for missing values and we're going to clean the data if it is needed. In this case, first off, we're going to check for missing values. So put in df, put in dot is null, put in dot sum, and that's it. So there we go. We have the values over here. And now what I'm going to do is that we're going to check for drop rows with missing age. So df equal df dot drop na. I'm going to make a subset equal, let's say here I'm going to define it by age, and I'm going to find out the missing rows with the value of age. Okay, so here I'm going to put in df dot over here. Also make sure put it in df, hit on shift enter, and it will basically, what it will do is that missing data can affect your analysis. So you can remove the rows where the age is missing. As you can see, there are a couple of these datas which are missing. Okay, so the next thing that we're going to do is we're going to analyze and visualize the data. To analyze and visualize the data, you have to perform basic analysis and plot visualization. In that case, like SNS or count plot. First off, we're going to find out the survival count. So print data frame, I'm going to put in survived. Close off these secondary brackets, value underscore counts. Hit on shift enter, and now you can see survived is 424 over here. Now, the next thing that we're going to do is we're going to plot the survival by gender. So how many female has survived and how many males survived. SNS dot count plot. Here I'm going to put in x equal. Here I'm going to put in single quotation, survived. I'm going to put in comma, q equal sex, and I'm going to put in comma, data is equal to data frame. Then I'm going to put in plt dot title, open the parentheses. I'm going to put in survival count by gender. Single quotation, and I'm going to close it off, and then I'm going to put in plt dot show. Now you can see that we have ddf, so we're just going to close off one of these, and now you can see we have the survival count by gender. You can also save it up as a photo if you want to. You can also take a screen snip. In that way, you'll be able to check how many passengers survived. And you can see 350 male survived over here. And you can see the female count is right over here. Okay. And what you can see over here is that we have explained how many passengers survived by using a bar plot to see the survival count and split it by gender. Okay. So basically, we are done with the 4 steps. Now, the last thing that you can do is you can interpret the result from your analysis, such as from the chart, we can observe that a higher number of females survived compared to males. So, gender seems to be a strong factor in survival cases. Okay. So, another thing that you can do or learn about in this class is you can understand how to work in Jupyter Notebook environment and identify and also handle the missing or inconsistent data and load and explore dataset. And also you'll be able to create basic plots and visualization and derive meaningful insights from data through structured analysis. In the same way, you'll be able to use these same features or let's say these same functions in other data sets too. Let's say if you want to work with, the floral part or the floral data set, you can also try using the exact same things. Except for that, what you want to do over there is you have to check the category of what you should validate inside of your commands or your functions as the variable. And also you have to check out what type of variable you are using. Okay, so that is basically it for this class project, and hope you understood about everything in this class project. If you still have any confusion or any question about any part of this class, feel free to ask me anytime. I'm always there to help you out. Now, the last step that you want to make sure to follow is take a screenshot of this whole thing and then upload it onto our project panel so we can check how you are progressing with work. So thank you again, and let's move on to class project 2. Welcome to class project 2. The name of class project 2 is Visualize the Key Patterns in the Dataset. In this class project, I have attached in a description and also an outcome. So let's get into the description. Students will investigate a dataset through visualizations using Python packages such as Seaborn, Matplotlib, and pandas. Through the use of the charts such as histograms, scatter plots, heat maps, and box plots, they will learn how to spot patterns, trends, and the relationships. Now let's get into the steps. First off, we're going to import the tools and load the dataset. Then we're going to get familiar with the dataset. Then in the third step, we're going to do is plot distribution. In step 4, we're going to discover the relationships between the dataset, or let's say the data. And in step 5, we're going to compare the categories. Now, what is the outcome of this class project? So we're going to make meaningful, understandable visualizations. We're going to select the appropriate chart based on the type of data. We're going to determine correlations, trends, and outliers. And we're going to use a Jupyter Notebook to visually present your findings. So the goal is to help students understand how to explore data visually to identify trends, outliers, relationships, and distribution. So without any further ado, let's open up Jupyter Notebook on our device. So we can see I have opened up Jupyter Notebook. Let's click on New and open up another notebook. Here, I'm going to put in, let's say I'm going to put in visualizing key patterns. Now, the first step is to import the libraries and load the dataset. So here I'm going to put in import pandas as PD, import matplotlib dot pyplot as PLT, import Seaborn as SNS, And then we're going to load the sample dataset. Here I'm going to put in PD or df equal pd dot read underscore CSV. Now, one thing that we want to do over here is we want to choose any of these data sets. We can try opening up these data sets and we can see this is how it looks like. Okay, so first things first, what I want to do over here is I want to load up my first data set and sample data frame. So I'm going to uncheck this, output.csv. Okay, this one looks quite better. Output.csv is good. We can also use example.csv. Okay, not example. Let's just remove this example.csv, remove it to trash. We can use either any one of these. We also have this mock data. Okay, so let's say I'm going to be using either mock data or the output. So let's go over here. And over here, I'm going to open up the parentheses. Here, I'm going to put in mock underscore data and put in dot CSV. Single quotation. And there we go. This is how it should look like. Now, the next thing that we want to do is we want to understand the data structure. So we can know what type of data we're working with, which is also going to help us to choose the right visual looks. So here I'm going to put in print df dot head. Then I'm going to put in print df dot info. And then I'm going to put in print df dot describe. There we go. We have all of these datas right over here. Now, the next thing that we want to do is we want to visualize the distribution, which is going to help us identify the skewness, spread, and outliers in numeric columns. In that case, first off, we're going to put in sns.histplot df, secondary brackets. You're going to define the column name. Let's say maybe I want the gender. In that case, I'm going to put in gender, close off the secondary brackets, put in KDE equal true. Secondary bracket or parentheses, PLT dot title. I'm going to put in double quotation or single quotation, distribution of gender. Close off the parentheses, PLT dot show. Now you can see the gender is going to be like this: male, female, and so on. Okay, so you can see we have the number of males, which are the highest, and female is a bit low. Okay, if male is around 480 or 460 or 70, then female is going to be somewhere around 420 or 430. Okay, now the next thing that we're going to do is we're going to identify the relationships. It's because we're going to be using scatter plots, heat maps, and pair plots, which reveal the relationship between features. First off, let's check out the correlation heat map. In this case, plt.figure. Open up the parentheses. Another thing that you want to do is open it up and type in the fig size. Equal secondary brackets, put in 10, 6. Close off the parentheses 2 times. Here I'm going to put in sns.heatmap. After that, open up the data frame, correlation, and here, comma, and not equal true, comma. I'm going to put in cmap equal poolwar. Single quotation to close it off in the same way. After that, close off the parentheses. And here I'm going to put in plt.title. I'm going to put in single quotation, correlation. Okay? Between features. Close it off. And here I'm going to put in plt.show. Now you can see there are a couple of errors right over here because it cannot detect up the data. And you can see there is a float data and NPNAN error in couple of cases. You can see could not convert string to float like value. One thing that we can do over here is we can change it into, let's say an ID value. Let's say if I want to work with ID. Now you can see there is still could not convert string to float Dimitri. So we're going to first off fix it up. First things first that we want to do over here, first off, let's keep it on 10. Another thing that we want to do is we want to create, let's say we're going to select only numeric columns for correlation. So here I'm going to put in a numeric underscore df equal df dot select underscore d types, which is going to be open parentheses, include, and type in equal. Let's say I'm going to type in number. Okay, this is how you want to put it. Close off the parentheses. And here we have df.core. Okay, so here before df, I'm going to put in numeric underscore df dot correlation. And anot is going to be equal to true, cmap is going to be equal to cool warm, and plt title is going to be the same thing. Now let's try hit on shift and enter, and you can see that it has been created. So it works because you are selecting the D types, which is going to only contain numerical values, which filters the data frame to only include numeric columns. And when you're using correlation or CORR, it works on expected since it only compares numeric values. So you're not going to face any specific errors. Now, the next thing that you want to do is you want to scatter plot example. In that case, here I can put in SNS dot scatter plot open parentheses data equal df comma x equal, then put in feature 1. After that comma, I'm going to put in y equal feature 2. That's it. Close off the parentheses. Here I'm going to put in plt dot title, open the parentheses. Here I'm going to put in feature 1 versus feature 2. That's all that you need to put over here. And type in plt dot show. There you go. This is how it might look like. If it shows you off an error, it is also totally fine because we also have to validate it only into numerical values. Well, basically this error shows up in case if your dataset does not contain, specific array of numericals. In that case, let's just open up another, let's say notebook. Here, what you can do if you want to do that, you have to type in, let's say a data frame. I'm going to use a quick test. Let's say SNS dot load underscore datasets. Let's open up the iris dataset. Close off the parentheses. SNS dot scatter plot. Open the parentheses. Data equal df comma x equal, let's say sepal length. Then we're going to put in y equal petal length. Okay, that's that I'm going to put. Then what we're going to do is that we're going to put in plt dot title sepal length versus petal length. This is what I'm going to put in. I'm going to put in plt dot show. Now you can see SNS is not defined. If it is not, it is also totally fine. Let's just import it. Import seaborn. There we go. Now you can see it will take a bit of time now you can see we have the data set. I'm going to put in iris, and there we go. We have the iris data set, which has been put over here. Now, another thing that we want to do is we're going to import matplotlib.pyplot as plt, and there we go. So we have all of these data, which is defined over here, and you'll be able to work with numerical values. You can also visualize categorical data where you can use bar charts, or let's say bar plots and box plots, showing comparison, group-wise insights, and data spread. In that case, what you can do over here is, let's say we're going to count plot for categories. Here I'm going to put in SNS dot count plot. Okay, count plots. I'm going to put in data equal df comma x equal, let's say here we're going to work with the petal width. Okay, close off the parentheses. You can see this is how it should look like. I'm going to put in plt dot title count of categories. Here, I'm going to, let's say instead of petal width, I'm going to put in species. Here, I'm going to put in plt.show. You can see there is no specific value. One thing that I want to show over here, I'm going to put in print df. You can see we have species over here. So let's just put in species like this. And there we go. We have Setosa, versicolor, and Virginica. Okay. Now, the last thing that we can do is we can count, and also we can use box plot to compare the groups. In that case, SNS dot box plot. This is what you want to put in. After box plot, put in data equal df, put in comma x equal, let's say put in the categorical column, let's say species. Here, comma, I'm going to put in y equal, let's say I'm going to put in the petal length. Okay, we have the petal length over here. Close off the colon and close off the parentheses. And here I'm going to put in plt dot title. Here I'm going to put in box plot of numeric by category. Here I'm going to put in plt.show. Now you can see there are a couple of errors like working like this. You can see first off we have species, and then we have this. First off, let's remove this data over here, and now you can see that it has been put into a box plot. Okay, Setosa is this much, versicolor is this much, and Virginica is this much. Okay, so now we have understood about how we can, visualize the key patterns in different methods, such as importing tools, getting familiar with the data set, plot distribution, discovering the relationship, and comparing the categories. So you can see in this specific data, box plot, and also this method of SNS or Seaborn is the most compatible and the best one to visualize the data. Okay, so thank you for watching this video up till the very end, and hope you understood about everything in this class. The next step, or the last step that you want to do, is you want to take a screenshot of this whole page and upload it onto our project panel to check if you or how you are progressing with work. If you still have any confusion or any question about any part of this lessons, feel free to ask me anytime. I'm always there to help you out. So without any further ado, that's it for this course.